Som. Pessoal, vamos nos acomodando.
Hello, folks. Let's take your seats. Feel free, take your seats. Be comfortable. Please come in. Welcome.
Som. Olá, bom dia. Sejam bem-vindos. Ele era um dos que ia falar, o Rondinelli, né? Deixa eu ver. Tá, vou pular. Tá. Francisco Rondinelli. Tá. Gente, mudou muita coisa. Tá bom. Aqueles que nos assistem online.
For those who are attending online through Zoom platform, we'd like to thank you. We are just waiting for people to take their seats, and we thank all of you for your attendance.
Bom dia.
Good morning. Welcome to the Latin American workshop on products and food irradiation. Please keep your smartphones on the silent mode. Before starting, give special attention to the security information. We have the fire extinguisher and two exits. In case of fire, the brigade will take you in a safe way from the main entrance to the external yard on this floor. It's a great pleasure to have the virtual attendance for those who are watching us from YouTube. Welcome. We thank our partner institutions, the National Council of Scientific Technological, CNPq, and the support of Latin American Association of Irradiation Technology, ALAT, the Brazilian Association of Agribusiness, ABAD, Brazilian Association of Nuclear Energy, ABIDAN, the Brazilian Association of Development of Nuclear Activities, and SENEM and IPEM. They made possible this workshop reinforcing the common purpose of expanding the reach of nuclear technologies in benefit of our society. We also have the following authorities: Vice Admiral Celso Nizutani Koga, Director of the Technological Center of the Navy in São Paulo; Supervisor Acosta, Superintendent of IPEM; Ms. Gislaine Balbino, Director of ABAG; Dr. Gustavo Varga, President of the Latino America Association of Irradiation Technology; Vice Admiral dos Santos, the first president of this company and president of Danúbio Brasil Participações; Rear Admiral Francisco Pontes, manager of strategic subjects issues of GSE, and also the president of the Brazilian Association of Nuclear Energy, the Rear Admiral Carlos Henrique Silva, and also president of Fundação Pravia, Dr. Andrea Figueiredo, general coordinator of sustainability and regulation of the Department of Agriculture and Cattle Breeding, and also Peixoto, from the Abidan, Dr. Maria Sovas, Chief of Food Irradiation in the National Commission of Atomic Energy from Argentina, Dr. Jiremenes Ribeira, President of the Bolivian Agency of Nuclear Energy, Gustavo Araújo Mascandi, from the Center of Nuclear Engineering in Agribusiness from the University of São Paulo. Thank you for your attendance. To start our activities, I will invite the Admiral Newton de Almeida Costa Neto to open this event. Good morning, everybody. I'd like to thank, I have to thank really that Amazon had this possibility of hosting this event here at Amazon. We are leading the process of implementation and development of irradiation, not only for food, but also for materials. You all know Brazil. We know about our capacities and our needs. We are a country where 1/3 of the GNP comes from agribusiness. We are an exporter country, but we are also responsible for waste. One third of what we have in our supply chain are food waste. And the reality is that we could export much more if we had well developed the process for food irradiation of many of the materials we produce in Brazil, especially fruits. It's almost impossible to export by plane. It should be by ship that requires a longer shelf life. But we are starting also material irradiation. We have medical centers in Rio and São Paulo where we could be using irradiation to leverage the health area. So all these entities in all these sectors, those who research, who make, who produce equipment, and who use and intend to use. This is a very important point to try to overcome challenges. When we look to the world, for instance, China, how much do they irradiate in food and material? They started from scratch as well. Don't we have this capacity? We need to overcome this challenge, the challenge of financing the installation. But we do have qualified people to study and create business model for each of these irradiation sector. And this is our purpose today, to discuss, to bring to a closer discussion so we can overcome the challenge. Who should I go for if I want to solve this problem? Who are the suppliers, the stakeholders, who will build the projects, and who is going to license? We at Amazon, we are working hard to overcome these challenges and to deliver something better to the society. The society deserves it. This type of work is to benefit this society. We are talking about safety that will lead us to food security. So I'd like to wish you a very fruitful day and take the benefit to do your connections here, to clarify your issues and to put some new on the table. So thank you very much for those who are in presence and those who are following us remotely. Thank you. So now I invite Dr. Isolta Costa, Superintendent of IPAN, for her initial considerations. Welcome. Good morning, ladies and gentlemen. I'd like, on behalf of IPAN, to thank for the invitation to be in this opening session. This collaboration between IPAN and Amazon is very important. We recently signed a memorandum of understanding, which the main purpose is to operate in the irradiation area for products and food. We are together doing this. This is to benefit the society for all in these countries. We have the possibility of increasing exports. Food irradiation is important because our country is where the agribusiness is very strong, accounting for a great percentage of our economy. So to make this bigger, to reach other countries, is a function of our small society that is united to make it happen. It is very important to have an effort to break paradigms in terms of the acceptance of the irradiated product by the society. This is something we should do together in this partnership. We have qualified people from IPEN. We have our manager of the Irradiation Technology Center, Dr. Ana Lúcia, an expert in this area, e Dr. Maria Helena Sampa, and last year she was the manager of the Irradiation Center. So IPEN is working together with you. Count on us. I wish you an excellent event, that have a very productive discussions, that we leave this event with a greater knowledge and greater interaction. We have people from abroad, we have Brazilians abroad as well. So all this integration will make this to be successful. I truly believe in this. In this union, we have the strength to make it happen. Thank you very much. We thank Dr. Isolda for the partnership between IPEN and Amazon. Now, representing our productive center, I invite to the stage Ms. Gilene Balbino, Executive Director of the Brazilian Association of Agribusiness, ABAG. Good morning, everybody. It's a great pleasure to be here with you. First, I'd like to thank Amazon for the invitation and partnership, and on behalf of our president, Luis Carlos Correa Carvalho, our special greetings to Admiral Newton and to our colleagues. It's a great satisfaction to represent ABAT in the opening of this important Latin American workshop, and promoted by Amazon with the support of institutions of excellence, CNPq, ELAT, ABEM, SENEM. The contribution to the sustainable development of the Brazilian agribusiness, integrating science, innovation, and environmental accountability. This event reflects this purpose, promoting dialogue between science and production, food safety and technology, present and the future of the food supply, food chain. The use of safe technology is recognized by international institutions like FAO and WC, represents the longevity of food without changing their taste and nutritional value, and strengthening the agribusiness in Brazil and Latin America. Initiatives like this reinforce that the agribusiness is above all an activity of knowledge and innovation. In these 50 years of evolution in Brazil, we work with science, technology, and innovation. This changed the country because this is Brazil's vocation. Brazil has a global highlight position and should continue to invest in technologies that increases productive efficiency and ensures security from the field to the table. This also opens new opportunities for the agribusiness to reach international markets since irradiation is accepted as a phytosanitary treatment for many countries. We already export to more than 250 countries, and we can increase this number, exporting products like fruits whose shelf life is very short. On behalf of ABAG, I want to greet Amazon for this workshop and greet all researchers, technicians, representatives of the public and private sector participating in this meeting. We show the debates will accelerate the adoption of technology that will ensure safer food and a more sustainable production. Have a nice event.
AG, que tem fortalecido o diálogo.
Thank you, Elaine. Strengthening the dialogue between agribusiness and innovation. Now we'll have Mr. Carlos Seixas, President of the Brazilian Association of Nuclear Energy, with his considerations of the nuclear energy in the scientific and technological development. Welcome. Good morning. I'd like to thank Amazul's invitation in the person of Admiral Newton for the opportunity of having a bang in this event. To be here is very important to have this interaction among several segments. Admiral Newton and the director of ABAG mentioned the importance of having agribusiness in the context of development in Brazil. It is important to have the private sector associated or present here. It's important for the nuclear sector to have this interactivity between the public and private sectors. We are working today to foster, to support, and trying to present seminars to disclosure the training of people who will work in nuclear sector. We try to contribute with universities, USP in São Paulo, and the Federal University in Rio de Janeiro. One of our concerns is the training of people and the maintenance of the acquired knowledge over these years. And today, with this food irradiation, it shows the importance of the nuclear sector in several segments.
And when you talk to general people, people tend to think about nuclear energy only keeping in mind the nuclear plants, but we know that's far more than that. And today, with food, radiation, drugs, and even nuclear energy, the nuclear submarines. I mean, there are several other industries or fields where the nuclear energy can be. So we are working towards training and not losing the knowledge that we gathered throughout those years when we've been developing nuclear energy. So I hope this is a great day that we can live here having more knowledge on this segment, and that we are able to disseminate so that this idea so that other people have a broader knowledge on the benefits of nuclear energy for our country's development. Thank you very much. May we have a great day. Thank you, Admiral. It's a pleasure to invite Dr. Gustavo Varga, President of the Latin American Irradiation Technology Association. Please, the floor is yours, Doctor. Good morning. It's a great satisfaction to be here on behalf of the Irradiation Technology Latin America Association. We can see electron accelerators increased use and X-ray increased use for several different technologies. Uh, it's been more than a century from the moment we discovered nuclear technology, but we still lack information disclosure. Knowledge makes us free. Brazil is a pioneer country, not only when it comes to technology, but also having the opportunity as the largest country in South America and a large food producer to show this technology to the world. We understand that most of the challenges are related to regulatory issues. So we see with as a great value the acknowledgement of this group, EPEN, the government, Amazon, because this joint effort will show us the path to move to the future. Food safety, it's for everyone, not for some. There are more specific and common uses, but as we need sterilized material, we also need to ensure food safety. So it's an honor to be here on behalf of Alati, meeting long last friends, and I wish we have a great workshop. Thank you very much. Thank you, Dr. Gustavo. Now we would like to invite Mr. Orpet Peixoto, representative of the Brazilian Association for Nuclear Activities Development, ABDAN. Welcome. Good morning, everyone. It's a great pleasure to be here on behalf of the of ABDAN as the vice president of the curatorship board. Our president Celso Cunha is in Brasilia, representing us in a nuclear event. So I would like to thank Amazon through Admiral Milton for hosting this event. A very interesting event, a very important event for the nuclear field. Well, here in Brazil, this is a huge country. We have today and we will have in the future a strong agricultural component, and radiation is completely linked to that. We we export to different countries, and we need irradiation to provide better quality food, and we need irradiation due to the size of the country itself. I'm talking about irradiation and its importance. So it's important to have an event like this where we can talk about the regulation, that we can deal and handle the irradiation regulation, and not only irradiation but the radiation itself. It's also important, but also encouraging companies, those companies in Brazil or even multinational companies with presence in Brazil that are seeking to enter this nuclear irradiation field. So this is a very important event, and I really hope that we have an effective event that was quite interesting for everyone. So once again, thank you, Amazon, for this initiative on behalf of Admiral Milton, and may we have a great workshop. Thank you very much. Thank you, Mr. Albert Peixoto, for Abidance collaboration. That's being active part of nuclear applications in Brazil. So to start this Latin American workshop for products and food irradiation, I once again invite the Director President Admiral Newton to open this event. Oh, this is just a formality, but we need to go through it in this event. So it's open the Latin American workshop for food and products irradiation. Congratulations and take all the benefit from this moment. Thank you very much.
Computador.
Please, I need to have access to the pointer. Okay, thank you very much. So we open the Latin American workshop on food and products irradiation. For the first speech, Dr. Cirilina Oraki, head of the radioisotope product and radiation technology section at International Atomic Energy Agency. She will share her perspective on the food radiation status around the world. Ms. Oraki is the head of the radioisotope product and radiation technology at IAEA on the physical and chemical department, nuclear department. She managed the science center for irradiation on the nuclear association from Argentina for more than 27 years, with a background on microbiology and food technology, post graduation on biotechnology and nuclear technology applications. She oversees activities including production of radioisotopes, radio drugs, non-destructive tests, radio tracers, and applications of radiation technology like medical sterilization, tissue banks, polymers modification, cultural patrimony, environmental protection, and food irradiation. This is the focus point of IAEA for the global initiative on the Plastic Tech Center, focusing on strategy and circular economy using radiation technology. Dr. Selina Orak, are you ready? Oh, 1 second, please. While we connect with the doctor, it will be an online presentation for those online. Wait for a few minutes until we have everything established.
Mais alguns minutinhos.
Let's wait a few more minutes and then we will start.
Estimados, ¿me escuchan bien?
Can you hear me well?
Tânia, se alguém se interessar, pode ir lá.
You can request your headphones and I kindly ask you to take your documents to me.
Ustedes me indican cuando puedo.
Can you tell me when I can start sharing my presentation, please?
You may start.
Nós conseguimos. Well, should I speak English or Spanish? There is no problem.
Ok.
Pode dar o ok para ela começar, Veloso, por gentileza? Tá tudo certo aí?
Estamos aguardando apenas a doutora.
We are just waiting Dr. Selena to share her presentation, as she mentioned.
Bien la presentación y en modo pantalla.
Can you see the presentation in presentation mode? Yes. Okay, perfect. So I'll start. Okay, then. This presentation is in English so that you can have a broader understanding, but I will speak in Spanish. If it is the case, I can change into English, no problem. Thank you for the invitation. It's a great pleasure to be part of this conference. And according to what we've discussed previously, this first presentation will be broader, not only for food, but applications, radiation technology, so that we can have an overview on the benefits. And then on the next sessions, we will dive on food. What would it be for food, agri-food, and other activities, related activities. And my colleague, the expert of the food department, tomorrow will bring more information on the last trends and the IAA perspective for the future. So that said, I will bring an overview on the technology and the different specificities of each, the different applications that this technology may be used for, also challenges and opportunities ahead. We were talking about the international, the IAA is supporting all member states. So a quick introduction. Why are we working at IAEA with this subject? This is part of our mission, our administration. So we have the power to enlarge and build competencies in member states. We support and facilitate all the necessary steps for knowledge development and also to have the necessary infrastructure for technology deployment. Among that, the radio technologies, radiation technology, industrial applications for health and food.
Well, this is manifested in two ways. The possibility of using radioactive sources, cobalt 16, cesium 137, in a very safe way, and all the management of these isotopes in a very safe way, and the use of accelerators as a radiation source for applications. So the IAI, they facilitated this so installations and capacities can be developed in all state members. Talking about radiation technology, we are referring to the installations that generate irradiation according to the source cobalt 60, cesium 137, generated by machines up to 10 megaelectron volts, and X-ray up to 7 megaelectron volts, according to the regulation of each country. And going into the details of each configuration of these technologies, about isotope sources, cobalt 60 or cesium 137, the way of irradiation is radio according to the source, the radioactive source. But there is a high penetration allowing irradiation. At the right, you see boxes that are luminous boxes. I don't know if someone is talking to me. I'm listening to very small voices.
En el tema de
Well, I'll continue. In terms of machine accelerators as uh, generators, source generators, in case of electrons, it is allowed up to 10 mega electrovolts. Globally, it's only allowed these energies. These are machines that you can turn on and off, and the way irradiation is generated, the electrons are accelerated unidirectionally, and the products can be irradiated with a good efficiency because the charge of the particles interact with the matter to break at a short distance. So they should be plane. And X-ray for machine irradiation, accelerated electrons that impact this break. So the X-ray you have photons with no charge. These can irradiate more boxes with higher values. And a brief summary of these characteristics in case of gamma and X-rays irradiation. You don't have a mass, no charge, so penetration is from good to very good. In case of electrons, these are particles with mass, charge, and therefore the penetration is more limited. But in terms of speed to deliver the required dose, in the case of electrons, this is really fast, unlike the gamma and X-ray. X-ray can be slightly faster. So, talking about applications and technologies in different areas that we are working, this is a graph according the dose range to have an overview on how we can control perfectly this technology to reach the effects. For instance, low doses up to 1 kilogram. We have a range of applications, some blood components, phytosanitary treatment to remove pests, and you can control in the field or after harvesting on fruits, irradiating the fruit directly to expand the shelf life, avoiding the rotting of these products in case of the shrimps and avoiding the sprouting in potatoes and onions. This is not under the point of view of food, but health, according to mode. And these are average doses and decontamination of dry fruits, honey, cosmetics, pet food, human food, and also for cultural issues. These are ranges of intermediary doses, thinking in the micro biotic application. Now we have higher doses for sterilization or decontamination in a clean room, reaching to doses according to the conventions. We can reach up to from 10, which is the convention for any method. So higher doses to ensure that the final product is ready to use, especially in contact with blood and human tissue. We are talking about prostheses, lab material, human tissues for graft, all necessary material in a surgery room. Now we are talking about a change of materials, polymers, particulation of some materials to improve their properties. Organic compounds, for instance, that sometimes are toxic to the human being and the environment, or even plastic that can be reused, gases, the greenhouses gases, and also the preparation of jams. These, according to technology, they require different time to reach the desired effect. So thinking about sector, especially the type of activity, we have food, decontamination, sterilization, polymer modification, environment, and blood irradiation. Now, I will briefly touch each of these fields of application. We start with food, food and agri-food. What we have here and how lower doses up to higher doses can be used from left to right. On your left, you see different types of application. So there is no generic application, but what we have are multi-applications reaching different effects. That's why I mentioned you can control the technology perfectly to provide the right dose to reach the effect desired without generating any adverse effect on loss of aroma or taste or nutritional products. We have a great possibility of action in activation of parasites, decreasing the speed of sprouting grains and shelf life, phytosanitary sterilization. This is increasing, and this will be something that we will talk about tomorrow. And we have shown that different technologies, since they are of low energy, we can decontaminate the surface after the You can also decontaminate the herbs and spices, especially in countries who do not want to implement this technology, but you can try commercial sterilization for immunocompromised patients or astronauts. They need stable food for a longer time, and also a new trend, which are the functional food. Modification in products, when you can food that can lose their allergenic effect, the alteration of some proteins, but modify some characteristics or process the product. Now, let's see the challenges. Why the implementation of this technology is not so wider? What are the opportunities we see now? We do have an increase in the adoption of these technologies, new markets interested, trying to invest in this technology. We also had great advances in technology, just like our electronics and household, who are more efficient, more compact. This technology also has developed. So we see an excellent improvement that applies to the purpose we want. So the process become more efficient and help in terms of time and costs. There are some regulatory barriers. There is no harmonization among countries about the regulations. And we need to overcome this. And also, the cost of invested capital is really high. But with these new technologies, we can have a lower cost. But we should not forget about the acceptance from the public. We have lots of material now that we can demonstrate that this technology is here to stay. And it also contributes for food security. So, reduce food waste and to improve the nutritional part of the food and make them available to more distant market. This contributes for several of these goals when you talk about food security. Now let's talk about healthcare applications. Main radiation applications are sterilization. More than 50% of medical products is sterilized by irradiation or radiation, blood products, because irradiation does not generate heat like other sterilization methods. So therefore, we can work with the frozen material. They can be sterilized without damaging any structure of the material. Blood irradiation as well, very disseminated. We have several technologies. And now cesium 137 are being used with the shield and compact X-ray machines, and this improves the logistic and availability of the technology, and it can also be used for synthesis of advanced biomaterials and nanostructures. Of course, this will depend on the materials, and this is also something that is improving.
As for the certifications of drugs, also transportation, well, we have nanochips, nano sensors, and other materials. We have different possibilities, application of possibilities that we've been studying in the latest years. So, what would be the challenges and opportunities? Mainly when it comes to a high amount of sterilized products, many of them are still being sterilized by gamma rays or gamma beams. There are problems in cobalt supply chain, the main fuel. It's not so accessible as some other sterilization methods. But we are working with the supplies so that we can have time sustainability. There is a concern on the a misuse of that source, so there is a trend of thinking, well, if we need to invest in a new plant, it will be for gamma irradiation or other types of technologies. This is still a challenge and may become a future barrier. But there is a acceleration on the use of those technologies, both X-ray and others, to enlarge the sterilization market, as the main sterilization methods. Well, we are trying to put them aside due to the environmental issue because they impact the ozone layer. So there is a strong trend to migrate to other alternatives. It is a demand for the last years and it's increasing gradually. As for food, the technology is increasing fast. Manufacturers are working so that the equipment settings and the plant settings are those adapted to this very goal. So they make investment and then they can recover, have the return over that investment. There are new plants being open. Many parts and components are already automated, what avoids human mistake. So we are advancing both in sterilization but multi-purpose. There are other methods and doses that I've mentioned, for example, for the contamination of cultural heritage. So when you talk about cultural heritage, this is a very effective technology from different perspectives. Firstly, I may be able to decontaminate, eliminating microbial bio organisms or even insects, those that may harm paintings. And we can also synthesize hydrogels. It allows painting cleaning without impacting or preserving the painting surface. It's being used more and more. Also on the consolidation of porous materials. So, for example, fragile structures that are impacted by time So once you you get it, you can use resins and other elements that may be irradiated, and as they are transparent, it seems to be the same original material, but now it has larger resistance preserving the material. So what helps in this way, we can preserve those art pieces. On the right we have two examples, Egyptian papyrus and this Roman boat that was found in a river. So what would be the limitations and opportunities for this field? There are many users of this very technology. Not all of them are familiar with this subject, so this is something that we need to discuss. But there is a great collaboration, whether because we are leading different action lines, providing training, developing protocols, but also we have a partnership with other agencies to develop methodologies or more accessible technologies. We have two collaboration centers to support the other member states, so to have access to that technology and showing its efficiency. So we have many opportunities on materials, cleaning agents, or resins, radiation curable resins that protect surfaces, including jewelry industry. There are many applications on that market. As for material modification or polymer material modification, they are well spread. We have know-how on wire irradiation, also tires. Many large tire companies have a black box to run this type of treatment. Many components. Well, 60% of vehicles are treated with irradiation in order to provide the mechanical resistance properties. It provides new functional properties, making this technology multifunctional. This is to show you some of the opportunities on using polymer modification by irradiation. If you think about production and recycling, there are many areas where we are already using it or areas that we may use, as it allows polymerization of tubes, pipes, wires, also sterilization. We are not changing the polymer, but rather the microorganisms' DNA. And as for recycling, we may change some properties so that a plastic that was used can re-enter the value cycle, coming back to the plastic chain. There are some other areas with large potential, and I mean microelectronics, irradiation, and surface engineering. and also on smart materials development based on combined treatments, like, for example, nano chips that we've been working with. As for environmental applications, and we are talking about low and high doses, there are several different application possibilities for greenhouse gases removal, water waste treatment, sludge ionization, plastic recycling, and the greenhouse gases mitigation. Irradiation is able to contribute on each of those aspects differently. For some, we are still studying, for others, we are already in the industrial scale. There are plans showing that this technology has great potential. So, what would be the challenges, opportunities seen on the environmental applications? Well, high capital and high operation costs. But now the technology is more compact. We have more adequate configurations, what will reduce costs, allowing to reduce the energy consumption. Well, when thinking about scaling due to cost or security, there is the possibility of implementing the technology. If you are able to have a combined treatment, in that case, the capital cost will be reduced because we are not doing one thing or another, but rather both, so that reducing the necessity of following all steps, what will reduce cost as well as you will demand less energy. Everything will be changed, and the benefits we can see on those applications are, well, by the advanced oxidizing event, we could observe the possibility to reduce contaminants that are not able to be done through other methods. So treated water or other types of water that could not be reused. Now they can be reused not as drinking water but for industrial use. What adds value to water, because water is a main point in our current water crisis. So we took a look on each applications, and now I would like to show you the current trends on radiation technologies. What we could see from the member states' demands, many countries are seeking to migrate from sources to machines, irradiating machines. So the current situations that we have 180 member states, from which only 40 have this technology. So there are many countries willing to start or advance to a larger scale. So, for example, a self-shield irradiator for a large plant. What we've been doing? Well, trying to find a way to go through, well, to implement this technology being deployed and accelerated, finding the best path for those countries that are looking to develop this technology. So we've been defining our own strategies. How can we identify the needs? And that's why we talk about country level needs, different countries, different working groups, different organizations. So we may invite member states to share their different needs. So we are now implementing what we call a shared initiative that integrates all the current mechanisms. So it's not about the integration of technology. We want to advance from concept to development and deployment of technology.
This also reaches the plastic recyclers or any activity that can mitigate the effect on climate change. Food security is another point, and also to avoid the dissemination of diseases also in animals. So we have several mechanisms that we can identify and improve the strategy, having a common line of thought. But also, we need to make accelerators uh, available, affordable for the state members. This is a shield uh, radiator. We have a lab at 9 kilometers of Vienna. We have a pilot accelerator that can simulate allowing the treatment of solid, liquid, and gases. In the case of solid, we can irradiate cables, wires, solids of all types, and a simple tray that will irradiate with a large scale irradiator. And this can be available to all countries interested in this technology. Now these countries can have a training for operations, preventive maintenance, basic treatment. Uh, all of this will facilitate when you need to generate the competences and train people. The problem we have is the adoption of this technology, because it's difficult to find qualified people to work on operations and decision making process. What is the right type of equipment according to the country needs, and what are the maintenance and operation um, needs? This is an overview of an electron accelerator. We have the energy of a zero point 0.7 mega electron volt, and you see at your right all the parts for liquid, solid, and gases where you can use the accelerator. And these are some volume characteristics, considering several types of accessories. My presentation can be shared with you later on. And the last point in terms of strategy to be more available to the member states and affordable as well, we have this need for implementers. So if you want to reduce the costs, this will be more affordable, requiring a lower cost of investments. And two specifications were developed, low and large scale. So all state members have the options to adopt what is more adequate for them. And here, these are the specifications. We call this a baby project and a star project. The characteristics necessary in this graph shows according to the power of several accelerators versus the energy. For instance, countries who will use in application fields for medical sterilization or food pasteurization. These applications, you can use it for several others, but these are the ones we favor first. And other points we see these two specifications that are a part of the coverage of the applications that the state members want. Baby project, 2 mega electron volt, and for star project in the installation you have the industrial scale, 10 mega electron volts and 20 kilowatts in average. And this would be a roadmap on how we could help countries in this system to be successful. Not buying the equipment alone, but you have to go through several stages to have the necessary capacity to implement and the right installation with the right equipment and training people, having all the licenses, considering authorizations and regulations, the regulatory authorities, etc. So we develop a strategy so the countries who are interested can do this in a very sustainable way. So if you go through this path, you can have better possibilities of being successful. You have the political issues, but it's not a question or a matter of planning. You have here a very good plan, and with this, you can be very useful. Research and development, we have several ongoing projects related to several actions, just to show in health applications, modifications of polymers, environmental applications, and cultural heritage. And we have a research system where we provide support in all stages, development, implementation, research, use the research in a coordinated way to towards a better good. And for governments, we try to generate knowledge to reach all the steps, starting students going to researchers at the universities. So we are developing e-learning tools and the credits to be recognized. And to conclude, how do we integrate all these activities? So we have a line of action, how the member states communicate and present their demands. Even in a presentation on a coffee break, you can start to discuss these conceptual ideas to create a new line of action or line of research. So these demands of the member states, they go to several mechanisms identifying the existence of a need, and this can be created and this will continue with the research coordinator. This coordinator participate with other research centers from all over the world to coordinate the results and compare them. Can be a basic research or advanced research, and even go into the treatment need, and then to see if the technology is mature enough. It can be worked with the private sector to make this transfer and to integrate this development, and then this can be disseminated and totally transferred. And as we measure the advances of this coordination is through the levels of technology, measuring the maturity of the technology as it evolves, and really ensuring that this can be transferred. With this, I close my presentation, and I thank you for your participation. And I'm just waiting for your questions and comments. We thank Dr. Horak for his presentation. It was an excellent starting point for our rest of the day. Now we will invite you for a coffee break. We we invite you to answer this survey. You have the QR code on the screen. If you want, you can send an email to veloso@amazul, and we can forward your question. Okay? Thank you. Have a nice event.
We'd like to thank you for your presentation.
I hope that it was clear and I haven't, I took a little bit more than expected. Sorry about that.
Thank you very much for your presentation.
Thank you and all the best.
Dear Miss Selena, thank you very much. We enjoy it. I'm sorry we couldn't have questions because our time is advanced now. Okay? Thank you very much, and enjoy your day.
All the best and wish you a very success symposium.
Não, isso eu não sabe. Ficou eu com o passador também. Som. Vamos retornando.
So let's come back. Let's take our seats. Please give me access to the pointer.
Vamos retornando.
So let's come back.
Mudaram então, porque não era
A próxima sessão ela terá
Next session will have 3 Spanish panelists. If you will to get the headsets, please, outside the auditorium, you can get them. Thank you.
Vamos retomando. Vamos
So let's resume with our agenda. I hope you had time for networking. I hope you had time to interact, knowing and meeting new people, new professionals. So let's resume. The Latin American Products and Food Irradiation Workshop puts together authorities and experts not only from Latin America but also European, North Americans, Canadians, and Chinese. This event counts with simultaneous translation both for Portuguese, English, and Spanish. In person attendees can use headsets that are available in the entrance hall, and those remote have three language options. So we will start the food irradiation centers in Latin America panel that will be moderated by Daniel Santos from the MSU Project Managing Office. Danielle, the floor is yours, please. Good morning, everyone. In this panel, we will discuss the experiences and advancements, challenges on implementing food irradiation centers on the different countries on our region. We aim to exchange knowledge among reference institutions, highlighting the strategic role of irradiation on food safety, international trade, and tech innovation. We are proud to count with experts from 4 Latin American countries, Brazil, Argentina, Bolivia, and Mexico, that will share the experiences and perspectives. We will have Dr. Thiago Mastrangelo from the Nuclear Engineering Center for Agriculture at the University of São Paulo, talking about irradiation centers in Brazil. Dr. Maria Constanza Cova, head of food irradiation section of the National Atomic Nuclear Energy for Argentina. Dr. Hortensia Jimenez Rivera, president of the Nuclear Energy Bolivian Agency, talking about the Irradiation Multipurpose Center at Bolivia. Dr. Geraldo Meave Flores, president of the eFoods Imports Inc., talking about the expansion capacity for food irradiation in Mexico. By the end of the presentations, we will have a Q&A session. In-person participants may ask their questions directly to the speakers, and those remote can send their questions through the chat. May we enjoy this panel, learn from this Latin America integration. To start the presentations, I invite Dr. Thiago that will talk about the Brazilian irradiation centers. Dr. Thiago is an agronomist from the Luiz de Queiroz Agriculture School, master and PhD on agriculture by the University of São Paulo, studies performed on the Atomic Energy Center at Austria, and from the Agriculture Department of the United States. He's the PhD professor at Agricultural Nuclear Energy School, in charge of the irradiation lab, working with agricultural epidemiology, pest control, agriculture defense, and nuclear defense techniques on agriculture and cattle breeding. Dr. Thiago, please, the floor is yours. Thank you, Danielle. Well, good morning. I would like to thank Amazon for the invitation. We have some speakers, so I will try to bring a overview on how the gamma radiation centers are distributed among within our country, in our country.
Olha só na tela. Para passar aqui, né? Certinho. Bom, vamos lá então.
Okay, so since 2015, I'm in charge of the food irradiation and radiotology from our institution. I'm an agronomist, engineer. So I'll tell a short story about the first irradiators in Brazil and what we have today. I will talk about the previous irradiators we had and the ones we have currently, and all the gamma radiators in the southeast region, CDTN, the multi-purpose from IPEN, and the CBE irradiators at Jarinu. So the food irradiation technique was introduced in Brazil by the end of the 1960s. The first irradiators came both for Sena and IPEN. At Sena, we got our first irradiator by the end of 1968 and IPEN 1974. Then we started to have large irradiators from 1978 on. And the food irradiation is being regulated since late 1960s. So we have a first decree from 1969 settling the standards for food irradiation. Then another decree from 1973 setting general rules for food irradiation, storage, shipping, a list of foods that could be irradiated. Then that law was declined. Now we have a resolution RDC number 21 from 2001 approving a technical regulation for food irradiation. So now we do not have a list of food that need to be approved in order to be irradiated, but now we have the minimum absorbed dose meeting a given specificity, and that the maximum dose will not be higher than the regulated one to avoid any food properties. We also have a technical opinion from phytosanitary measurements for pest control. At Dr. Calvo thesis, he brings this table. So in 2005, we had 7 gamma irradiators in Brazil with maximum capacity between 3 to 5 kilocuries. From those 7 radiators, 5 were manufactured by Nordion, Canadian company. So our first irradiator came to São José dos Campos 1938 for Johnson & Johnson in order to irradiate their own companies. It was more, medical equipment, needles and others. Then Embra Hudson brought 2 irradiators, one in 1981, another one 1999. Then CBE, the Brazilian sterilization company, Jarinu, 1999. Then Tech Ion Manaus, 2000s. Then the CDTN irradiator in Belo Horizonte, 2012, almost 60 kilocuries. Sena had a semi-commercial irradiator approved in 2002, a FAPESP project that was approved, but then there was a problem with the Public Execution Office. They even received material for the transport, everything, but it was never installed. This irradiator was never used. So we have 2 smaller radiators with cobalt 60. IPEN has a large multi-purpose irradiator that start operation 2004-2005. So we could say that from the 1980s, the radiators start to come to Brazil. So we have 7 radiators, and yesterday I accessed CNE website. So we have the cobalt irradiators. We have 7 of them. We have from the CDTN, about CBE, the multipurpose from EPAIN, Johnson & Johnson irradiator, and the 2 ones from Cotia. So basically we have 5 plants. We can see Buscamed Brazil, but as far as I know, they have a Gamma Cell 220. It's not a large radiator. They used to have a X-ray radiator from Radisource, a polyfunctional, but became obsolete. Now they have a Gamma Beam 220, and then was donated to Brazil for Muscamed in Bahia. So we have few irradiation centers in Brazil. Basically, we have 5 or 7 centers. Well, about companies with electron accelerators or X-rays, we have a higher amount. So we have about 15 centers. Most of them are private companies, actually. Tire-related companies like Bridgestone, Goodyear. They may be accelerators for polymerons. So most of them are located in the southeast region of the country. So let's talk about Sena radiators, one of the first centers to work with irradiation. So if you don't know, this is our center at Piracicaba. Basically, we had 2 cobalt 60 radiators. The older one, Gamma Beam 650, and the other, Gamma Cell 220, in the building here in this side. Some pictures from the opening of the center, 1966, by the former governor. Sena was linked to the federal government. It spent 12 years being managed by the nuclear agency. So we got our first radiator in 1967. So the AIA brought this radiator to irradiate materials that were surrounding the equipment. So this Gamma Beam 150 was a full irradiator lab founded by Professor Federico Endel. He was from Exalc. He left the institution. He founded this lab. So later on, Professor Julio Walser worked in the lab, working together with Professor Walter Arthur. The first researches were for commodity depesticization and agriculture depesticization. We have a video from 1971 showing Gamma Beam 150 work in 2 minutes video. I think it's worthwhile. It's worth to show you this one.
Em 1966, funciona em Piracicaba o Centro de Energia Nuclear na Agricultura, SENA, anexo à Escola Superior de Agricultura.
Tem um labirinto.
Here, the atom disintegration is not used for destruction, but rather to preserve food. The atom radiations are providing better food, better beans, rice with higher proteins, and flowers that even nature has never created before. Death only for the pest impacting the harvest. Sena technicians destroy fungi and insects from all species, analyzing water and stones. They discover more effective fertilizants. Nuclear research for agriculture has started in 1950s. 3 years later, it started in Brazil with a leading position in this industry for Latin America.
O homem aprendeu a usar.
We've learned to use atom medicine, controlling its power that makes humans so weak.
Graças à
Due to the isotope application, we have today 96 new varieties of plants and fruits. Senna imprisons the atom on the benefit of the Brazilian development.
Esse vídeo ficou bem legal.
This is a great video. We need to update it actually. So in the video you could see the first Senna irradiator gamma beam 150. With it we had hundreds of researchers and studies. We had by that time the first food irradiation course in 1968 with the support of FAO and the agency. We had some experts from Israel, Lupo, Roche Calderon, Indian, Americans, but we saw the need to refuel with the cobalt 60 to go to at least 6,000 hits. But by that time, it was cheaper to get a new irradiator than changing the source. So we got the second Senna radiator, gamma beam 650. It was donated by the agency as well, and it was installed in November 1974 with almost 30,000 curies, 29 something. It was in the same bunker of gamma beam 150. So there was this protecting door. Oh, could you go back, please? So there was this lead door. This video, okay.
Não.
Let's check if we can watch the movie. Okay, so we have these corridors and then we have the radiator. This is gamma beam 650 from 1974. It worked from 1974 to 2025. So we were able to irradiate seeds, food bags. Here we have another video, if you could play. This is a quite interesting radiator. We had 12 steel tubes and the cobalt capsules were here above the tubes with 2 air compressors, so they are floating. In the beginning we were able even to expand tubes to its maximum reach, 64 centimeters. But with the radioactive decay, now this year we had less than 40 curies, so almost no radiation. What limited the researchers, we could irradiate no more than 2 liters PET bottle, so we couldn't irradiate food anymore. So it was not useful for researchers anymore. We have a gamma cell 220 that was acquired by Professor Augusto Tillman in 1999. A FAPES project. It was acquired by $130,000. One of the most sold in the world. In 1999, it has 2,600 kihis, and now 88 kihis. We would need to decommission it. So we cannot irradiate with those kihis. The research center, well, we provide some services for third parties, but we focus on research. So we have 130 post-graduation students. In the last 5 years, more than 1,000 papers. As for food irradiation to fuel, we've been working more with sterile insects, but we had great researchers, mainly with gamma cell for mutation induction in plants. So this research line led by Professor Augusto Tuman, they've developed different cultures like rice, beans, some flowers, citrus. Professor Júlio Walter and Walter Arthur researched food and irradiation, combining process with heat, modify atmosphere, irradiating tropical fruits, bulbs, tuberculosis, chicken meat, and others. So anything above 1 kilogram was quite complicated.
When I came back to Sena in 2015, we have a pilot plant built in 1988 by the Department of Agriculture, and with the radiators we needed a new equipment, and since 2015 I was trying to find a new radiator for Sena. There is a company in the US, a world leader for blood irradiation, and they have interesting models. And they develop a moment with the two X-ray tubes that could work with food irradiation. This model, which is RS 420, works with the two X-ray tubes and also external to cool these tubes, and we can insert up to 5 canisters, 50 liters each, so with 5 kilos of material, irradiating up to 25 kilos of materials. This is the image of the radiation chamber. Here we show this canister. You can fill in with material and then you take it to the radiation chamber. You can get up to 7 grays per minute. Gray, not kilogray. It's been used in the US and Canada for the cannabis industry to sterilize the derived products. This equipment was donated by the Department of Energy of the US, and in exchange we could decommission the old Gamma Beam 650. This model is 420 hot source with 100,000 dollars. You see all the specifications here, and it works with the 220 vac, and depending on the density of material can generate a dose rate of 6 to 7 gray. And it was installed in 2024. Now the radiators we have in the southeast, we have this irradiation lab starting in December 2012. It's a multi-purpose irradiation panoramic. You see the entire room, maximum activity after 2200 terabec, used for blood components, blood treatment, and also pharmaceutical, jams, and the cultural heritage. This is the epane radiator. You have this concrete skin pool, and it has two grades with 404 lapis of cobalt and 13 sources of cobalt. This is very interesting. It can irradiate almost 6 tons of material. They do a lot of research, but they irradiate third parties material. There is a great demand. And this, what is a big company, Sterigenics, that acquired CBE in 2015. They have the E-beam since 2002, 3 irradiators. We radiated this material. It's a high cost. The minimum cost is 7,800 reais. So the cost depends on those exposure packaging. In 2020, the cost was almost 4 to 5,000 reais per cubic meter. Then it varies, $60 to $80 per cubic meter. But people came to me every month for this irradiation, but we didn't have capacity. Up to 10 kilogram we can irradiate at Sena. The maximum is 25 kilos of material. This is what I had to share with you. Very rapid. Thank you for your attention.
Agradecemos ao Dr. Tiago pela excelente
Thank you, Thiago, for the excellent presentation and for data for the Brazilian experience. Now, we invite Dr. Maria Constanza Cova to talk about irradiation installations in Argentina. Dr. Maria Constanza Cova has a master's degree in industrial quality. She is the head of food irradiation of the atomic energy of Argentina. She has 17 years of experience in research and development in food irradiation, participating in several national and international projects in partnership with university and scientific institutions. Good morning. Thank you. I especially thank Amazul for this opportunity, for this so interesting exchange. The idea of this presentation is to give you a brief overview, due to time, of the installations that can irradiate food in Argentina. First, I will talk about our institution, the National Commission of Atomic Energy. We have 3 atomic centers, our agency created in 1950 for research and develop of nuclear technology, to motivate, to foster technology innovation and apply the science. We have 3 atomic centers. All of them are in the province of Buenos Aires and atomic center in Bariloche, the Fundação Bautel. Our national commission is present all over the country through different regionals. These are the 3 atomic centers and a headquarters in Buenos Aires. The focus today is in the atomic center in Eucência. where we have all the labs and plant that provide services for ionizing radiation. This industrial, the core is the heart would be the core of activities that goes to the management of applications and technologies of radiations. And all these labs and divisions, they are in the Celsia uh, Atomic Center and covering all the applications: food, biotechnology, apiculture, environmental, polymeric materials, bioremediation, and insects, entomology, working with projects of generic dose for some species, and a microbiology lab. We work in collaboration of a high dose dosimetry lab. It's a reference lab in our country. This management, we have services provided to companies that want to implement technology. I will talk about food, so which is my area. We have several institutions and with graduation and post-graduation on nuclear technology, consultancy services for those who want to implement, and the strength is research and development. We have two irradiation plants that can provide services for food products and also industrial, which is the estatal, which is the National Commission of Atomic Energy, is the ESEISA, and the Geonics with the two irradiating unities. Both plants are multi-purpose. They go from low dose to high dose. You see, Argentina is a thin country, and the two irradiation plants are in Buenos Aires, and we have a limitation here for potential clients who could have access to this treatment. These are pictures from Ionics, a private company. I'm sorry, I cannot disclose information about numbers and volumes of processed products. It is placed in Partido de Tigre, 30 kilometers from the city of Buenos Aires, opened in 1988. In 2017, they opened a second radiation unit. They have two radiation units in the same plant. One operates with 1,220,000 curies, and the license of operation is to work with these amounts. This is the Ionics plant design. There is a labyrinth system, irradiation chamber, and the source is shielded, armored, using the same design of the plant of the Atomic Energy Commission, and they provide their services for all these products, food, irradiation, but today the strongest is the medical products sterilization. Anyway, irradiation is used in food products and dehydrated food or ingredients. This is more favorable treatment because it keeps the characteristics. We cannot apply heat. So many companies with microbiological and sanitary standards for this type of spices and beef and cheese, they require this radiation technology to avoid contamination during the process. This irradiation plant of the uh, National Commission is the first in the country, opened in 1970. The cobalt sealed sources are provided by Dioxitec, and it's a private plant. Argentina is producer of cobalt 60, so all industrial plants operate with cobalt 60. They are authorized to operate up to 1 million curies, and this brings industrial, semi-industrial, and scale, and also they do irradiation for samples for research and development. This is the mechanical transportation system, the same way as the private company. It's a labyrinth with water. The nominal activity is 1 million curies, and the two irradiation plants are authorized and licensed by the nuclear regulators in Argentina. This is a survey we did this year with data from the state plant, PC. So food product, unfortunately, accounts only for 10% of the products processed. The strength is the sterilization of medical products.
Among those two products categories, well, it's well balanced actually. Sterilization and decontamination doses. We are also including food. The total volume on irradiated products is about 320 tons. Medical and hospital products, and then among the total amount, 340 tons. We also count with a storage. We have gamma cell that were sent back to the center and it was refilled. So we have gamma cell for sample irradiation research, insect irradiation for sterilized insects researches and researches related insect related researches. Well, I am always saying it's coming, it's coming. It's arriving, a accelerator, a linear accelerator that would be arriving in 2026 in a project for technical cooperation with the IAEA. As I said, it would be one of the baby projects. In Argentina, we still do not have any electron accelerator for food treatment. There is one in tires company, but not for food. This would be the first one for food. So the idea is to use it for research and development, and also having the possibility to external clients to use the electron accelerator. So a group of colleagues visit our institution so that they had some training sessions and handling training sessions. Well, the projects that doctor mentioned with this accelerator, this is not a low energy accelerator, but rather a mid energy accelerator, but we can use low energy as well that will decontaminate products on surface. So it is well fit for superficial decontamination without the negative impact in the whole product. How do we work in our atomic center, in our department? When we have a customer, a client, we access the microbiological problem is to eliminate pathogens or to increase shelf life. So understanding the best process for irradiation, because we may irradiate some ingredients or the final product. We define the minimum dose. So for a given client, we can use a different dose range. Whether it is a if it is a higher scale treatment, we define the dose range. The client even don't know the range when they come, so we can advise them and provide the minimum dose settlement, settling the minimum and the maximum doses. We can help them to decide the maximum dose that the product will accept according to trials, clinical trials, and other elements. And then we have the validation process, the process validation, accessing the dose range and the final phase and dimensions of the product that will be irradiated. And then we can keep moving with the parameters and the routine treatment. As I said, among the technology and application management, we have different labs. Exception for dosimetry, the other four labs rely on the process radiation department. So we have microbiology for medical products, dose irradiation, or for food decontamination range. The entomology lab working with research projects related to pests. We also have the food radiation lab where we set the maximum dose, and polymeric materials, because in the case of food we may irradiate packages, check its characteristics, or even to irradiate products for decontamination. Those would need a sterilized packaging. Here is my contact information, our plant phone number if you need any type of information. We also have our webpage address, and our motto is we irradiate confidence. This is my contact information. Thank you very much. Thank you, Dr. Constanza, for presenting the radiation framework in Argentina. Now I would like to invite Dr. Hortensia Jimenez Rivera to talk about the Bolivian Multipurpose Irradiation Center. She's a chemical engineer with Sustainable Energy Development master's degree in Canada, general manager of the Bolivian Nuclear Energy Agency, and a core role on the Bolivian nuclear program, using peaceful nuclear energy usage in the academic development of the country. It was the vice minister of alternative energy and author of the electrical industry sector nationalization in Bolivia. Developed some public policies on sustainable energy development. Thank you for your attendance. The floor is yours. Thank you very much. Good morning. Thank you, Amazu, for the invitation, for this very important forum. where we will talk about irradiation. A subject today is a very critical subject on food safety. This is a moment to share knowledge, experience, and to talk about potential integrations when it comes to experience and technology. I will talk a little bit about Bolivian nuclear industry.
Pode dar o acesso ao apontador, por gentileza. Obrigada.
Ah, tengo que mirar para allá. Bueno, muchísimas gracias. Bueno, primero en principio decirles de que cómo empezó.
Well, I will start telling you how the nuclear subject came to Bolivia. It was in 2014, and then 2015 the Bolivian nuclear program was created. It wasn't something random. It was thought as a tool for the country development. So through the long-term plans, the 5-year plans, they've decided to incorporate the Bolivian nuclear program for peaceful nuclear technology usage on agriculture and industry, health, and natural resources. Well, so it always started in the 1960s, as many other countries in the region. It was created in the Nuclear Energy Commission that focused basically on uranium and nuclear medicine. Then that group was disassembled. We got the Bolivian Nuclear Energy Group working with the lack of license. Well, a little bit of licensing, a little bit of researching, but working mainly with X-rays. From 2015, it was decided to incorporate into the planning the nuclear technology use. So 2 agreements were signed. One with Argentina for the development and training of human resources, and with the Russian government. So that in 2016 we've created the Bolivian Nuclear Energy Agency, and the agreements were ratified for the creation of the Nuclear Technological Development Center settled by law. There was a prioritization on building the Bolivian nuclear program and Bolivian Nuclear Center. We had the first call to bid with Russia in September, and then with a law in November 2017, it was defined the construction of the nuclear center as a priority for Bolivian national development. As you can see, there were 2 important subjects to support this project. The first one, the political will, and the budget itself. That are part of the national treasury. It was financed. Well, it was financed by private for the restate companies, the restatized companies, and then it was signed an agreement with Argentina for building 3 medicine nuclear centers, and then another bill, another law. It was authorized the the Bolivian Nuclear Agency start to provide scholarships for research. So we now have two institutions that can provide scholarships for nuclear research. Why is that important? Because it was decided that both agreements should be components of the specialized training on human resources for each area. There were other elements like Decree 3498 and 3574, allowing to release the credit letters to fund those researchers. In 2019, the the nuclear peaceful applications law was approved, and a decree and a decree where there is the separation between the regulation and the operation and research. Through that decree, it was created the surveillance authority.
Is created.
It was created a surveillance authority to regulate the nuclear researchers. In 2020, the construction was stopped, not only due to the pandemic, but because in 2019 we had a coup d'etat, and due to a lack of political willingness, the program didn't move on. 2021 we had elections, and those projects were retaken, so that in July 2021 we started to build the research nuclear management center. Then 2022 the medicine nuclear center, and then 2023 we built the preclinical psychocontrol center, the gamma multipurpose center, and the nuclear medicine center from La Paz. As part of this process, so by law we've defined the safeguards. So when it comes to the program, the Bolivian nuclear program components, we have 3 medicine nuclear centers, 6 linear accelerators, 3 PET-CTs, and the chemotherapy centers, so that to have all the cancer treatment circuit.
So we have 3 fundamental pillars. Each of these installations provide services to the society and research, and is also a school. We are training professionals and graduating professionals in the radiotherapy area. We have the radio pharmacy. We have a Canadian reactor that reaches up to a higher dose, and we decide to have a large and a small reactors. This is our reactor, and this is our irradiation plant. This is the timeline for building this multi-purpose plant. The contract was signed in 2017, then design was approved in 2018, then 2020 we have this stop. Then we had the transportation of the radioactive sources from Russia. In 2023 it was open, and 2025 the operations, commercial operations started. When we got the licensing, it was a short time to comply with all the requirements. But we have some entities with a larger financial support, and we end up depending on the regulators that makes the process much more slower. So now, with this security and safety issue, we have all the documents, the operation documentation, maintenance documentation, and in 2024, we had the approval from AGEMED, the medical authority that regulates the radiation applications in healthcare. In 2025, we had the food radiation, and we hope that next month we will get the ISO 9001 certification. You see our design in Russian and Spanish, the building part. This is the arrival of the radioactive source that went around the world to reach us, licensing, training. It was a group of 15 Bolivian young people who went the Polytechnical University in Russia for this training. It was a theoretical training, then we had the hands-on. And this is our self-shield irradiator and the larger one. Concerning the specifications, the Russian company that designed and built, the capacity is of 12 kilo curie. It is a dry storage, and in the case of the industrial radiator, we have a capacity of 1 million. We started with 100 curie, and we had a stage for getting the knowledge and also to talk about the subject with our potential clients. And the purpose was to promote the technology. We work with milk, banana, sugar cane, wheat, born. We have in Cochabamba and La Paz, and we work also with the agro business and cattle breeding in La Paz and other projects such as the sterile insect. This is very important because we have a pilot plant in Santa Cruz. We did lots of irradiations, and now we are testing the doses. But 4 or 5 institutions that got together in this project, Senatac, and some other regional projects. These are some other pictures. This is who has just presented that was part of the International Atomic Agency to help us in this designing and training people. Well, the most important is to have human resources and make them sustainable. We are working with different universities to keep this long-term sustainability. This was on the day of the opening. And this is a panoramic picture of our research center. This is the irradiation plant, the radiology lab, and here we have a nuclear medicine center and radiotherapy. And here the headquarters. Thank you.
Muito obrigado à doutora Hortência pela excelente apresentação.
Excellent presentation. Thank you. Now continuing and closing the presentations of this panel, this phase, we have Dr. Gerardo Meve Flores, president of eFood Imports, and we'll talk about the expansion of the irradiation capacity in Mexico, food irradiation. Dr. Gerard is online, and he already with us. He is a founder of a company, Avante Magic Clean, in IBIM Agroindustrial in Mexico. He is a mine and metal engineer, graduated in Mexico with a PhD, master degree from the Arizona University. Recognized about E-beams and X-ray irradiation for medical disposable devices. He has a network of companies in partnerships with the National Research Center of E-beams. Fresh products to meet the requirements for exports and the industrial infrastructure in Latin America. For more than 15 years, he has been promoting e-beam technology in several countries in Latin America, Europe, Asia, and Africa. He is recognized by the national security, nuclear security from the United States for the safety role in electron accelerators. We will start showing a video requested by Dr. Gerardo.
IBIM Agroindustrial es una empresa
100% Mexican company dedicated to this, localized strategically in the heart of Mexico. Thanks to the connectivity of the infrastructure, you see in Mexico, we have the transportation from all parts of the country up to our plant. Our privileged location serves the Pan American port, and we are closer to the port of Mexico, connecting the Pacific Ocean and the north and south boundaries of our country. The agri-food sector of our country is supported as well. The technology is the best ally to the improvement of the food sector. That's why we have implemented the technology that goes beyond the current process, keeping the food fresh. With this technology, we have the safety of the product and a better shelf life, allowing more reach to the markets, and also the trust in this food that can be good for health. We are the best in the world allied with to the best of the world to attract them to Mexico, developing a unique infrastructure in the entire Latin America. And we have a great center of food irradiation. We have dedicated and qualified professionals providing quality services and innovative solution that meet the requirements of more demanding markets. We have the national and international food security supporting the health of the population, and we have a technology approved by several food and health agencies, ENCA, ASKIN, AFIS, and Senakita. And the industry, we see clear the opportunity of services and the quality of the radiation treatment. This technology is the most advanced in the world with an automated services that can irradiate one box up to a complete pallet. Our system has moving sensors and a specialized software that provides trackability for every pallet since it exits the plant until it's delivered to the client. So e-agro-industrial is an important part of the value chain of the company requiring phytosanitary treatments and to comply with the norms and standards of the national and international market. And we mark a new era in quality and care of food security. We have a team that cares for the health of people, the environment, and the industrial support to the companies in Mexico. Better and fresh food for longer.
Doutor Gerardo, o senhor nos ouve?
Yes. Buenas tardes. ¿Me escuchan?
Sí.
Good afternoon. Can you hear me? Yes. Very well. Okay. First, I'd like to to thank
the name that I would like to invite for this important workshop. Planting innovation to harvest development. So I would say that once again, I would like to thank for this invitation to participate on this event. It's a great honor to attend this workshop organized by Amazon because this is a very valuable perspective. And for e-agro industrial, it's important moment for us. We see reality fulfilling a joint dream that today puts itself as hope on a shared lesson that the seed we plant together is not only technological but the desire for sustainable development, bringing possibility for all countries that you represent. We could see that some previous participants Unfortunately, the food irradiation participation on their projects are very low when comparing with sterilization, debacterialization, or depestization. But it's not because it's not necessary, but rather because basically we need to motivate farmers, people, products from other companies to use and export their products to the United States and other countries. What this plant, the agro-industrial plants represents, not the future, but rather the present, that we reach with a leadership spirit and people like you that basically are the ones fostering the projects so that they can bloom and consolidate, becoming drivers for the region. Your your excitement on this Congress is the proof that when you have willingness, when there is innovation, the limits are overcome. So we have intellectual capital, a huge one. In the previous presentation, we heard people saying that there are 38 years people going to different universities and learning and studying. Well, I would like to tell you that for the 3 plants that we work in Mexico in partnership with other shareholders, we have the best students from the universities because we had a direct partnership, what improve our work and improves the full participation of universities. All the students that we have in our Mexican plants are Mexicans and they are very young, less than 30 years of age. So keep in mind that people like you representing your countries in other countries, this is a energy that we see from the leaders so that those projects can be put in place, and that this is a proof of excitement and the willingness that you have for innovation, and that we can remove limits. The leadership team that we have in our plants at eAgro Industrial, basically they have a full effort and we keep learning in order to expand our borders, to expand the limits of the products that we have. And when we had the financial presentation of the first products, and we already have 7 of them, now we have more than 207 potential customers. I really hope that this work, all this learning process, and this joint effort, I hope that we can move forward because all the institutions here, we bring experience from different institutions, different countries, and they will share with you their knowledge. I hope that this video, it was a simple video, but you could see our agro-industrial plant. I'm here for you if you have questions. I will open room for questions if you may have about our plant operations. Thank you very much.
Muito obrigado, Dr. Gerardo, pela sua contribuição. Encerramos assim as apresentações desse painel.
Thank you, Dr. Geraldo. So I would like to thank all the speakers for their speeches. We could see similar efforts in the region and great improvements. Now we will start the Q&A session. I'd like to invite the speakers to come to the stage.
Participantes presenciais podem.
Those here in person can raise your hand so that you get the mic to ask questions. Those remote may send your questions through the chat.
Bom, boa tarde a todos.
Good afternoon. I have a question that I think will be of general interest. The Mexican experience was impressive with modern facilities to irradiate with exportation in mind. So I'd like to know, how do you see the possibility, or what is the pathway to convince for the investment on food irradiation, because we know how hard it is to be in this communication process, training process on the advantages of irradiation, but there is some resistance from the investors. So what would be the strategy so that we can easily convince the investors, the entrepreneurs, the business people, so that they can embrace this cause and invest in this technology? Do we have any volunteer to answer that question? Well, I think that we are all here to talk about it. At least from our institution, we work with communication disclosure, but this is not enough. Many times communication happens in the scientific and academic environments. It's hard to get the market itself. There are some debates with entities from the industry, but what happens is that there are several factors where we all should be aligned and we are not. So tomorrow we are going to talk about regulation. This is an important blocker, more in some countries, less in others, but even though we need to have all levels represented so that that engine can run smoothly. And at least I can talk about my country. We need a more strategic perspective, a state policy on where we want to go with food irradiation, the advantages of it, the markets we can reach, the impact on food safety, and especially a coordination among different public entities related to regulation, control, technology disclosure. And of course, we need to work on communicating with the consumers. Well, we have few years of experience, but what we've done was based on a principle of having contact with different industries, with trade chambers, exportation chambers, industry chambers, to show and also to bring them to visit our plants. We are doing so in showing our exporting potential. We also do the same with the International Trade Ministry, telling them there's a world of possibilities for that technology, for the irradiated products. This is what we've been doing. In my opinion, well, for public institutions, it was so hard to get licenses, allowances, and permissions. Many people have interest on that, but we didn't have the licenses in the past. So it is important to share information, to share what's happening. When we talk about the general people, it's important to think about the impact and the economic willingness. For example, Bolivia is a small country when comparing to Brazil, Mexico, Argentina, But for us, we have the possibility with this using those silos where we store grains and controlling price by controlling prices as well. This is something important. So there are some lines you can use to convince people about the positive impact of this technology. So we are attending all business rounds. We are always there in the last fair, in the last Congress. We were there. We showed irradiation. We've disclosed irradiation. We've been using TikTok, other social medias. So we've been using all types, ways, means of communication so that we can show the positive impact of this technology. Another important topic, something that was important for Bolivia, the first nuclear facilities that we put in place were nuclear medicine centers, and they were nuclear medicine centers. Now, this terminology is not bad anymore. We've changed the idea on the nuclear technology. Of course, some people make confusion between reactors. Well, reactors save lives as well in a given way. So, this is another important management on the communication strategy. The communication strategy that needs to be applied to media. So this is a core element so that we can start from the public agencies. Well, sometimes, I saw some economic analysis on cost benefit that for some productive chains and some products, there's no cost benefit as installation cost, maintenance cost. So in some industries, the process is too expensive. So when we're talking with the business people, they say, okay, this is too risky, so it's hard. But if you have a high valued product, well, what happens that once the economic analysis shows profit, then you can move on that conversation. Otherwise, if there's a cost thing, then they stop the talk right in that moment, and okay. Dr. Geraldo, please feel free to
contribute with the discussion.
Ele estava falando em inglês.
I think we need the private initiative. So we are in this learning moment, in a moment to advance, to move forward. Books were published about the advancements on food irradiation. We have those cases of success, and we need them to give some steps forward so they can move forward so that all countries have technology. There are many countries far behind on this technology. Foods like fish.
Foods like fish and seafood. We know already the benefits of irradiation in these products. And in the case of Mexico, I would say I had to go many places to talk to businessmen, banks, academic institutions, and with the government, and especially those who produce mangoes, so they could all understand about the safety and the benefits it brings. In the case of mango, you can make it last up to 2 months, just like a guava or a papaya. So you can export to other countries. In the case of pet food, many people today, they have their pets, and this is a sector that is growing. So we do have a very large market, and I believe that the FDA will approve it because the demand is too big. And countries with this type of technology, they bring incredible benefits for the academia, for the producers. It is possible to use this technology in many ways. So the benefits are endless. Now, concerning grains, you can store them from 5 to 7 years. It's incredible. So please go to the universities and universities who have already studied this. When you have the opportunity of seeing this, I said, I need to apply this in Mexico because we have so many benefits and advantages that are being used and will still be used to benefit Mexico.
Boa tarde.
Good afternoon. I have a question about logistic. This irradiation center, is it better to be closer to distribution and ports or closer to the producer or in the way from the producer to the distribution? Well, probably closer to the port, to somewhere to distribute. Here in Brazil, it would be better being multi-purpose, closer to a port or airport, because the producers, the farmers, they are very decentralized. It's difficult to have such a big center close to one farmer or one producer. So logistic is very complicated, and here in Brazil the freight cost is big. We did a work with pepper producers from the Espírito Santo. They want to irradiate the extract. We did it. It increased the shelf life even more than 6 months. Excellent. But the problem that the cost of freight to send São Paulo to irradiate here and then send to Santos or Espírito Santo, the freight cost was so high and impacted so much the final cost of the product that they didn't want to proceed. If you allow me to complement, once you mention how logistic impacts the sterile insects and how expensive is it to send the insects to the producers. Well, you can produce many millions of insects, but to send these insects, sterile insects, to other state is very, very expensive, especially air transportation. The cost is very high. In the case of sterile insects, the source should be the closer the better. In our case, we had several points together. We try to clear this justification. This plant is in Del Alto 4 meters higher. Well, this is Bolivia. This is a mountain. Maybe you don't have anything there. Maybe a potato. But the large um, supply centers, they are more to the west of Bolivia. But anyway, we are a Mediterranean country, and most of the products we export, we go through the Pacific Ocean. Well, going from the Altiplan, this was a way to justify why we built it there. But in addition, there was no other place accepting us to build the plant. And there was some discussion on in the east part of the country. They did not produce any mosquito, but they have an orange plantation. In the center of the country, we produced hortifrutis. So we show in the center, in the case of mosquitoes, we send the mosquitoes for meters, and we sterilize, and we send them back. And we think this will, okay, and we also look for smaller radiators for other areas of the country. I'd like to add that there is a great potential for the phytosanitary treatment to grow. We will no longer use methylo, but since radiation plants has a high level of radioactivity, and the transportation system does not allow you to transport large volumes, so we need to think about radiation plants, gamma or accelerators, closer to ports, so they could group the producers, and with the public-private investment, with the site and the fruit producers, they could create or build a plant for large-scale processing. We don't need to debate that much. The best is to be closer to ports. The first truck that I crossed the US crossed 2,000 miles. So the fact of having plants in high up the mountains, the centers will not be successful, because the user, they want to sell to the entire world. So the solution is to be close to ports. This way you have a better design of your plant with more advanced technologies. So think big. And this is how you're going to develop new projects. We have manufacturing companies now that are really developed, highly developed in phytosanitary products. All countries, Bolivia, Ecuador, Colombia, Argentina, Brazil, they are rich countries in raw material, and you should benefit from this. You can join these manufacturing companies. In the case of IDA Solutions, one of the largest companies in the world, but we have others that can solve your problems. The point is, you need to have one main characteristic, motivation to develop these plants, and you have raw material, and you have important ports going through the entire Americas and the world. Hello, good morning. I'm Gustavo. I work here for Amazon. I'm not from this area, but we saw many solid food in the presentations. And what about liquid food? Milk, for instance. What would be the technical barriers for this liquid food? I, 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 I only saw solid food or pasty food. Well, in general, milk would not be a good food for irradiation. Thermal treatment would be better because it's liquid and will have an indirect effect of irradiations due to the high water volume, and this would impact to get a sterile milk would require a high dose, and this will not be compatible. But we can do have applications in liquid food. For instance, we have a project with the University of Buenos Aires, which is a vegetal shake, antioxidant fruit shake, and it works very well because we have the green tea combined, some natural products, and when combined, you can apply lower doses, and it really increases the refrigerated life shelf. Yes, some liquids can be treated, not milk, but we have other options. Well, milk and cheese, the higher the liquid content, you need to be careful with the balance. So even low doses can cause oxidation, changing odor and taste. So the higher the lipid content, the radiation is not a good option. You need to be careful with this. Thank you. Well, due to the advance of time, we need to close this panel. So those who still have questions that were not asked, please send to us or talk to us during the breaks. I'd like to thank again your presence here and also our audience who participated in this debate. And I hope that these discussions we started here may become new partnerships, research, and concrete advances for food irradiation in our region. Thank you. Well, our morning has ended with very valuable reflections about the radiation centers in Latin America. We'll have now a lunch break and we'll be back at 2 p.m. Okay? So enjoy the break. Thank you.
eu vou precisar de som. Mais rápido que eu. O apontador, meu amigo. Não esquece do meu apontador. Para não jogar fora o crachá. Obrigada, minha amiga. Não vai ser só eu. Acrescentar, acrescento rapidinho quando eu falo aqui. Tá bom. Olá, vamos voltando.
Hello, let's come back. Let's take our seats. Let's take our seats. Is everything okay with the live? Yes? Okay, good. Hello, let's come back. Let's resume. We hope that you have enjoyed lunch, that you had a great network. It's the right moment for that among all participants. So now we will resume our agenda with a panel called Food Irradiation Technology that will be moderated by Arius Kabi, Radiological Protection Assessor at Amazon. Good afternoon. This panel, Food Irradiation Technology, was thought so that we could introduce the new technologies on food irradiation being studied by Amazon. For this panel, I would like to invite Dr. Suresh Pillai, Master on Industrial Microbiology, and a PhD on Microbiology Immunology by the Arizona University. Dr. Suresh is current professor and chief of the food department at the Texas M&A University, where he published more than 340 articles, including environmental effluent irradiation, food irradiation researches, and medical products. Dr. Suresh Pillai was from the advisor board of FDA, from the American Society for Microbiology, and currently he's the director of the National Center for E-beam Research at the Texas A&M University. Dr. Suresh Pillai unfortunately could not be here in the workshop, so he will not be able to join us even remotely. So he sent us a video, about 30 minutes video that he sent us. So please, we can play the video.
This is the outline of the presentation. I'll first talk about the National Center for Electron Beam Research at Texas A&M University. What is it we do? And some of the recent activities as it relates to Latin America. I'll then make a small statement on why we need to switch to E-beam and X-ray technologies. I think many of you know why. But I think it's always important to emphasize the most important points, because there are many in the audience who probably may not understand the deep differences. Also, I want to clear up a major misunderstanding of these technologies. I hear many subject matter experts talk about E-beam, cobalt, X-ray as though the technologies as you're very different. And I want to mention why they are not different at a molecular level, why it's the same technology at the molecular level. And I hope you appreciate this effort I make for you to understand it, because in today's world, clarity of information that you communicate is extremely important. And then finally, I want to end up with the story about the beauty of electrons. So, at the National Center for Electron Beam Research at Texas A&M University, we've been doing a research related to E-beam and X-ray since 2002. It's a 20,000 square foot facility. It's the largest facility anywhere on a university campus, anywhere in the world. So we are a very unique facility. More important than that is the dosimetry systems that we have. We have state-of-the-art dosimetry systems. We have at least 5 different dosimetry systems. We have the alanine system, the B3 graphchromic system, the graphchromic, the B3GS dosimetry, the graphchromic film dosimetry, the ResoScan, as well as the temperature calorimetry for original dosimetry measurements. We are an ISO 9001 certified facility. We are inspected by the FDA and the USDA-FSIS, and we are regaining our certification as a USDA APHIS facility. Very importantly, we have been also almost 25 years of experience with R&D in this domain for different applications, all the way from food, water, polymers, etc. Obviously, we do a lot of the effort is for the peer-reviewed original publications, so that we keep pushing the boundaries of science. Also, we train graduate students, undergraduate students to be innovative thinkers and thought setters. So we challenge them with very unique projects, and we expect them to come up with some new IP or some new findings completely, so that then that makes them deserving of a PhD or a graduate degree. We spend a significant amount of effort on our activities with the research industry, with the industry, industrial research. So we work with companies to perform these R&D projects. Our funding comes from both government and private industry. So we understand what the government needs, we understand what the private industry needs. In addition to R&D research, we also have commercial experience of using the technology. So when we talk about E-beam may be more efficient than X-ray, or X-ray is good in this aspect, We talk about this with a lot of authority because we do this at a commercial scale. We sell commercial e-beam services for the last 25 years. And we do food, phytosanitary treatment, animal feed, pet food, etc. We have strong collaborations with US government enterprises such as ORS, Office of Radiological Security, the EPA, and CERDEP, which is part of the DoD program. Our mission of the center is to harness e-beam technologies for cleaning, healing, feeding, and shaping this world and beyond. What we mean by that is we do fundamental research and translational research to do research related to environmental remediation. We do similar research related to novel therapeutics or vaccines. We do similar research related to food security and food safety. And also, more recently, we have started doing quite a bit of work on developing novel plastics or upcycling plastics, etc. So that is, and then beyond is our work that we do with NASA and other space agencies. So this is the reason why we call ourselves, or our goal is to harness these technologies for cleaning, healing, feeding, and shaping this world and beyond. The work we do, even though we have been doing this work since 2002, in 2014, the International Atomic Energy Agency called us up and said, hey, we noticed that you're doing some very interesting things similar to what we want to do, and you are the only center in the world that's on a university campus that is working in this area, and we like you to be a collaborating center for food, health, and environmental applications. So we are an e-beam collaborating center, IEA collaborating center for food, health, and environmental applications. We were designated initially in 2014. It was renewed in 2019, and now more recently it's been renewed in 2023, when we expect it to be renewed a couple more years down the line. In addition to our collaborating center status, we are also a center of excellence for the National Nuclear Security Administration, very specifically in low energy electron beam technology, and that is to accelerate the transition for the use of radioactive sources. We all know that cobalt-60 is wonderful, it has done a tremendous amount of benefit for mankind, but it is time to change. And the only way you can unleash private industry is if you change it to alternative technologies, because that becomes sustainable, there is economic prosperity, and you're not dependent, held hostage by a country. Also, any part of the world can access machine sources or alternative technologies because they are safe, there's no proliferation issues, and they're very secure. And ultimately, we are also very, very interested in harnessing e-beam technology to secure, protect, and strengthen the US economy. So the different types of activities that we do span research, development, and commercialization, as well as outreach and education. So as you can see, we do work in food safety, food quality, phytosanitary treatment, environmental remediation, sterile insect technology, polymer modifications, plastic upcycling, crop mutation, and tissue banking. And then we also, part of our outreach and education, in addition to teaching graduate and undergraduate coursework, we also offer hands-on e-beam technology workshops in partnership with the technology providers, and we also invite potential technology adopters. But very importantly, we also partner with governments and international banks to help them access this technology. As part of enabling them to access the technology, we work with countries at country level and develop feasibility studies, technology feasibility and financial feasibility. And these are not simple studies, these are very detailed, that last from anywhere from 6 to 12 months. And this is very, very detailed studies. They're not business plans, but they are documents that an investor or group of investors can look at and decide, is this something that we want to invest in? or at a government level, somebody can take a look at it and say, wow, we did not know that this technology could help us solve this problem, and at the same time, we can run a facility that is financially feasible. So that's the goal. We are very fortunate in being able to be entrusted with such opportunities by many governments around the world. But so the bottom line that we emphasize is there are business opportunities in every one of the e-beam applications, whether it's pre-harvest agriculture, post-harvest agriculture, environmental remediations, or new materials, or sustainable energy, or vaccine development. There are potential business opportunities. Now you may ask, well, what business opportunities are there? Well, that depends upon the company or the group that are adopting the technology. So it is not just selling e-beam services which become profitable. That is not what we are talking about. We are talking about companies wanting to use this technology for a particular product. Now I want to emphasize about global vision is to, as I mentioned, we bring best and the brightest ideas, and we tell them use the e-beam technology as just a lab tool and figure out how you would use it to come up with novel processes that are commercially viable. When I mean commercially viable, it's not that the product is sold, etc., but somebody can actually invest in a novel idea that somebody then you continues to use e-beam technology. We are not saying that every idea that a researcher comes up with has to be patentable or commercially viable. All we want them to do is, this is not, yes, we are very interested in publishing original research articles, but at the same time, the center sits on a university property, and we need to be very sensitive to the client's needs. So we want this to be published as much as possible, presented as much as possible, and then disseminated as much as possible. We do not want these ideas to hide in some journal article. But what we do best, and what I think very few centers can get close to what we do, is what I call the Texas A&M or Aggie sauce. We don't build the technology, we don't make the equipment, we are not the end users, and we may have an IP portfolio that's about 12 or 15 products, but more importantly than that, what we really do is we bring all the players together. We bring all the players together within the Texas A&M University umbrella and make it an extremely comfortable environment where the company can talk to the technology end users, and then we bring together the banking end groups, the banking groups, the investor groups, the local, regional educational institutions, and the regional and local regulatory bodies. This particular ecosystem that I call this is really what we are very good at. We know how to build these ecosystems for these projects to be successful. Our goal is to finally help educate entrepreneurs to build successful e-beam or X-ray facilities worldwide. Next slide, which you all know there are two separate technologies on two sides, gamma and e-beam and X-rays, and I'm showing only the linear accelerator part of it. There's rototron technology, dynamitron technology, etc., etc. But you all get the idea that this is machine-based sources and cobalt radioactive. So when you do that, you create electron beam technology. You then realize that the energy can be switched on and switched off. There is no loss. It is based on electricity, and there's no chemicals, radioactive materials, or security issues. So, simplistically put, this is how the electron beam technology works, and I hope I'm not insulting all of you by this simplistic schematic. I'm sure that there are at least few of you, at least one of you, who will value this slide, and this presentation is maybe designed just for that one person. But basically, this is the electron gun. The electrons get accelerated through this vacuum tube, and then it comes out in a steady stream of electrons, a beam of high energy. It has a very high dose rate, 3 to say 3 kilograms per second, very high throughput. This has implications for the speed of the treatment, also the speed of the throughput of the product in and product out. It has ramifications to the cost, and also, but the most important thing, the packaging has to be customized. This is very important. You see a lot of people still thinking, oh, E-beam does not penetrate. That is nonsense. E-beam will penetrate, but the amount of penetration depends on the energy of the electron. But also the packaging has to be customized for the particular energy that is being used. I know Dr. Gustavo Varca is in the audience. He will tell you how effectively he was able to use maybe a 3 to 4 MeV E-beam system for a variety of different packaging. Now, so don't let people tell you that E-beam will not penetrate. Yes, maybe less than a 1 MeV, the penetration is very, very minimal, but anything over 1 MeV, there is some penetration which can be harnessed. Now, associated with E-beam is that people constantly use X-rays, either with a rototron or a linear accelerator. The features of X-ray is that it has a lower dose rate than E-beam, but it has a lower throughput than E-beam, and is not as cost effective as E-beam. Now I want to go through and explain the reasons why it has a lower dose rate. If you see here, now this is the same whether E-beam from linear accelerator or E-beam from rototrons. The electrons coming out of here are the same. But to generate electrons, I have to generate photons, I have to put a tantalum shield or a X-ray converter. What it does with X-ray conversion is that it converts these electrons into photons. So they all become photons, and because they are photons, they can penetrate deeper into the material, but still I want to emphasize, the particle that does the job are still electrons. Now, the point is lower dose rate is, here it is. It is taking E-beam, which by itself is quite inefficient, and making it 10 times more inefficient by converting, by slowing down these electrons by this tantalum shield, and photons are created. Yes, it penetrates, but the dose rate is much, much, much lower. So then the throughput is also low. Why is it not as cost effective as E-beam? Well, because it is lower dose rate, which means you must take a longer time to treat a product. And also here you can see the efficiency is lost converting electrons to photons. And then in the product, the photons again get converted back into electrons for doing the final job. So it is almost in my mind, and I'm hoping to be proven wrong. I mean, industrial scale, there's a lot of X-ray development going on, but it'll be a matter of time to understand how cost effective is X-ray truly. So here, it is penetrating, it is cost effective, but it is going to be at least a minimum 10 times more expensive. Not only will the treatment cost be expensive, and that is because the time it sits to take the to deliver the dose. Also, the electrical consumption is also significantly higher with E-beam, with X-ray than with E-beam. Now, this is a schematic of an E-beam facility, and I'm sure that you have seen many, many images like this, but it is a very established technology, very cost-effective technology. It is adopted all around the world. I was recently in Philippines, in a small town high up in the mountains. They have an E-beam facility operating with a very, very beautiful equipment. Now, the good thing is, if you're a private investor, and I asked you this question earlier, why would you want your core, if food processing is your core competency, and you need to make the products pasteurized, and you desire to use ionizing technology, why would you abdicate that responsibility to a government agency to buy cobalt for you? There are machine sources that are available all around the world. It's like an ice cream store. You can buy whatever flavor that you want, whether you want low energy, medium energy, E-beam, X-rays, duo, all different combinations, scalable, changing power energy levels, etc., etc. So, and there are a lot of dependable commercial companies out there. There are multiple applications of this technology. In Brazil is a pioneer in this technology, so I don't think I need to be explaining all the different applications. But in foods today, these are the different applications. In pre-harvest or post-harvest, there are e-beam technology mounted on trucks that go around in Europe, treating the surface of seeds so that they germinate better. It is not like treating thousands and thousands and pounds of ground beef, but it treats a lot of seeds. And offering the e-beam on wheels for seeds is a big business in Europe. Also, Tetra Pak in many parts of the world have e-beam inside the equipment. Now, it's very important here I want to mention, if you are an entrepreneur who does not have any background in e-beam or X-ray technologies, you just want a technology that does the job. This is how easy it should be. You buy something from Tetra Pak, it does all the things that you want, and they just tell you, oh, by the way, we do not use chemicals. We have a small e-beam system inside. It is completely integrated. You don't even see the difference. So that's how seamless this technology has to be. Obviously, there are fixed facilities like Steritech, and both in California as well as in and Australia, as well as so many commercial e-beam X-ray facilities. This is the only technology that spans across 4 different areas or 5 different food safety domains: food safety, food quality, phytosanitary treatment, and food packaging. These are the countries that have been approved to ship products into the United States. I want to challenge Brazil. Why isn't Brazil on this list? Or here's are countries like Jamaica and Grenada, the Dominican Republic, and all these countries are on the list, but why isn't Brazil, such a large country in Latin America, not set up to ship products into the United States? I say that with tongue in cheek. You don't need to export to the United States to make this business viable. Very, very important. Do not believe that exporting commodities to another country is the only way to make money. Brazil, China, India, and other large countries have such a large population that if you effectively and strategically deliver irradiated or pasteurized or electron beam treated products to grocery stores within your country, there is no need to be exporting to countries and having to face tariffs and whatnot. You don't need to develop markets in other countries. There's a very large, big consumer population in Brazil, and they'll be more than willing to consume products that you make. As long as you have enough e-beam or X-ray facilities in the south of Brazil, north of Brazil, etc., so that you never have this problem of shelf life storage and shelf spoilage of fruits, etc. So I'm glad in a sense to see Brazil is not here, because I think Brazil is prepared to expand the technology in such a large way that you can use it inside Brazil. Contrary to what many people say that, oh, there's consumer resistance, it's absolute nonsense. This is a data slide showing the volume of imported irradiated products, fresh produce coming to the United States from different countries between 2019 and 2022. Do keep in mind the year of 2020, which is COVID. In spite of COVID, you can see here there was a 53% increase in the volume. So this clearly shows that people will buy, lack of a better term, irradiated food or irradiated fresh produce in the United States. There is absolutely no consumer question. So if people keep asking me this question, whether is there consumer, I have lost patience. I just ask them, if they ask me, how do consumers have a problem, I say, what are you basing that on? Why did you even ask this question? They say, well, some people, I read it on the internet that consumers don't like it. I say, well, on the internet, I also read that the earth is flat. Please don't waste your time and my time going after these so-called myths or anecdotes based on pure fiction that people will not buy. In my mind, the reason people use that argument is because they are intellectually lazy not to make the inquisition or the questions to understand the true status. So today in 2025, there is absolutely no resistance in the United States or in any part of the world. The reality is not that the consumers will not buy it. Consumers will seek out these irradiated products. And how they seek out these irradiated products is very important. As I mentioned, most of Walmart and other stores in the US are very large grocery stores. But they drive the price of commodities down. They force sellers to sell the products low. Case in point is Pakistan. Pakistan brings Pakistani mangoes to the United States for treatment, even though Pakistan has an e-beam facility. In Pakistan, they'll use the facilities in the US. They transported by one plane from Karachi to Dubai. Then in the Dubai airport, it's moved to another plane and that comes to Houston, Texas. From Houston, Texas, it is taken by a truck to Gulfport, Mississippi. And in Gulfport, Mississippi, it stays for about 24 to 48 hours. It gets treated and shipped all over the United States. So within a span of about 80 hours, the product has already left a mango tree in Pakistan and is already in somebody's kitchen table. This is incredible in today's supply chain world. But I want to emphasize the second point here. If you go looking for Pakistani mangoes in Walmart, you will never find it. You will find a lot of Mexican mangoes in Walmart. The reason is Pakistani exporters of mango, they sell a mango for $5, while $5 a mango, while Mexican mangoes are 75 cents a mango. And the reason for that is, this is how the Pakistani mango looks like when you purchase them. You are willing to pay for this money. Now you may ask, where are these mangoes sold? They are sold in ethnic stores where the Pakistani shop, the Asian shop, the Indian shop. So they are sold in these ethnic stores. They don't feel the pressure that they have to bring the price down. There's a willing and well-heeled people who are willing to pay the price. So what I want to emphasize here is that if you use this technology with good post-harvest handling, consumers will pay a premium for quality. This is very important to keep in mind. In Mexico, we initially had conversation with an entrepreneur who built Mexico's first e-beam facility in Tijuana. That same entrepreneur is now inaugurating a second e-beam facility next year. And there's also another entrepreneur who's part of that group who's already opened an e-beam X-ray facility in Aguascalientes. So this technology is growing very, very fast in Mexico. In Pakistan, as I mentioned, they don't treat it in Pakistan, but the volume of it going to the United States helped a company get financing from the banks to build a facility in Pakistan, but they don't use that facility in Pakistan. They rather use that facility for irradiating spices and medical supplies, etc. Now, this is another important point. Consumers will seek out irradiated food, but the more important point I want to tell you, if you own and operate an e-beam or X-ray facilities, the price you can charge for fresh produce is significantly less than the price you can charge for spices. And so if you have an option, you will only do spices or medical devices. So this is the point that I want to emphasize, is that fresh produce phytosanitary treatment finally may get used or might be built by companies that specialize only in phytosanitary treatment. But even that, once again, only time will tell. This is just a quick map to summarize all the parts of the world where this technology exists. It doesn't mean that every country at the dot has only one facility. It just means that country has that technology. Brazil has an e-beam facility in Brazil, but as you can see, the rest of Latin America has very limited technology. Africa, once again, is missing a lot of this opportunity. So conclusion, what I have concluded is that e-beam and X-ray technologies have advanced and matured significantly. People are increasingly purchasing irradiated foods. The building of these new facilities in different parts of the world is boosting exports, accelerating economic development, and adding substantial value to food products. It is attracting significant investment from non-traditional investor groups, and also is creating new high-paying jobs. So that's why I call it the beauty of electrons. Also, I want to mention the IAEA calls it the atoms for peace and development. I say it's electrons for health and prosperity. Finally, I want to make a plug for the 2026 e-beam workshop at Texas A&M in April. This is a QR code that you can use to access a website which has all the links, and I hope to see many of you there. I know Eros was here in 2025, and I hope, and others were here in 2025, and I hope to see many of you from the Amazon, not only from Amazon Corporation, but from all of the attendees, many of the attendees at this conference at Texas A&M University. So thank you very much, and I'm sorry I couldn't be there in person, but I hope I was able to convey my key messages. Thank you.
Prezados, então esta foi a...
So that was the speech from Professor Pillai. I apologize for him on his behalf. And if you have any questions that I may send to him, we will do so, and then we forward you the answers. Thank you very much. Thank you, Eros Carby, and thank you, Professor, who recorded his video. Thank you very much. So now we'll have a showcase of presentation of X-ray installations for irradiation with worldwide reference companies on applying those technologies. This session was created to disclose equipment and installations of the provider companies so that you can get closer to those who are interested on settling a irradiation center. We invited 5 companies, although only 2, AIBA and Mavix, could attend the event. On this showcase, we will have 2 presentations, 12 minutes each. So we kindly request the presenters to respect the time so that we can provide isonomy among the participants. Let's invite to the stage Mr. Gregory O'Brien, director from Beam Applications. Please.
Invite Mr. Gregory O'Brien for his presentation. Thank you very much.
Boa tarde. It's a pleasure to be here to speak with all of you today. and please forgive me for speaking in English. I want to begin by thanking Amazul for putting together this very important event for all of us to participate in so that we can share information on the use of beams for phytosanitary treatment.
I'm going to ask apologies for Mr. O'Brien. Mr. Mauro Ferreira is going to fix up your presentation. And so we ask Mr. Scott Carter, no, Miss Stephanie Chiarotto for her presentation on MEVEX. So we are going to change the order here. I'm sorry. You'll be back.
Thank you. Thank you to Amazul for having us here. We're happy to be here and share some knowledge about our product offering. I like this side better. Okay. So my name's Stephanie Chiarotto, and I'm a technical specialist of applications engineering working for MEVEX, Asteris company. And today I'm going to talk about the MEVEX dual modality system, X-ray and E-beam for food irradiation. It's not clicking. Oh, sorry, can I go back? Got it. Thank you. So MEVEX has three main business segments, which together provide a turnkey irradiation system. We design and manufacture our own linear accelerators in-house. We offer a variety of product handling systems from box, tray, tote, and pallet conveyors to complement our linear accelerators and match whatever the customer's needs are. And we also have developed our own process control software to integrate the system and manage the process. Our turnkey phytosanitary product offering includes the radiation source, conveyance system, and process control software. Our systems are designed to be easy to use, so with the click of a button and the scan of a barcode, once product qualification is complete, the system is operational, knowing what to do automatically. Our phytosanitary systems are traditionally pallet-based conveyance systems to maximize throughput, and we support both X-ray and E-beam modalities through the use of a retractable X-ray converter. Our X-ray dose rates are perfect for low-dose treatment for phytosanitary and food irradiation, whereas our 10 MeV E-beam mode opens the door for high throughput at sterilization dose levels. So just a little bit of background to MEVEX's presence in the food irradiation industry. We installed our first food irradiation system in Thailand in 2018, and since then we've continued to grow our install base to include 5 phytosanitary and food irradiation facilities located globally. Within this install base, this includes both case and pallet-based irradiation systems. And this is just a note that this is just our presence in the food irradiation systems. We have installed over 100 linear accelerators globally. Here we have a couple of pictures taken during our installations in Australia. They had their first system installed in 2019, and in 2023 they had their second system installed in line, which doubled their power and consequently doubled their throughput. Linear accelerators can be used for a variety of applications, including phytosanitary treatment, microbial reduction in food, sterilization of medical products, cross-linking, bioburden reduction for herbs and spices, and more. Our linear accelerator phytosanitary system is designed to balance the primary use case, which is low-dose treatment under 1 kilogram for phytosanitary, along with the complementary products, which is higher doses of 5 kilogram or more to fill the schedule between harvesting seasons. Our irradiators have the capacity for up to 400,000 pallets, depending on the dosing requirements during peak seasons. We offer 24/7 service support to maximize system reliability and minimize downtime. And because our systems are capable between switching between E-beam and X-ray mode, this allows for the processing of products across multiple industries and applications. All of this is possible while keeping the capital and operating costs to a minimum and having upgradable options to address both the present and the future needs. At the end of the day, flexibility directly translates to efficiency. So by having a system that can do both E-beam and X-ray with high throughput of both, it's minimizing the initial capital investment and operating costs. So I've said dual modality a few times, so I just wanted to show what I mean by that. We have the tantalum X-ray converter and the scan horn. Right now, the X-ray converter is out of place, so the electrons are coming out of the scan horn to have E-beam mode. But with the press of a button, the converter can slide into place. The electrons penetrate through the tantalum converter, creating photons and therefore having X-ray mode. To allow for some of the products to be E-beam process capable, this is just an example of how some of our customers have arranged the products on the pallets to allow for the penetration of the electrons through the product. And while beam utilization can be more efficient in E-beam compared to X-ray, E-beam isn't necessarily better than X-ray. Both have their own advantages, and each product and product geometry will have an optimal modality. Having the flexibility to process in both E-beam and X-ray with a single system allows you to maximize your throughput potential, as well as reduce the operating and capital costs. Our typical project timeline is about 18 months from the execution of the purchase agreement to the completion of system qualification with IQ and OQ. After the system is qualified, 24/7 technical support is available through our service team. And how we accomplish the 24/7 technical support is having 4 locations located globally, covering all of our time zones. Our headquarters is based in Ottawa, Canada, but we have service teams located in Europe, Asia, and Australia to help support our customers. And then just a quick video that we have here from our most recent food irradiation facility installation in Aguascalientes, Mexico. It was very quick. I should have slowed down the speed. But thank you so much for the time, and if you have any questions, let us know.
Você ainda tem 4 minutos. Temos.
No? So, may I ask you a question?
Sure.
What's the lead time?
O tempo do pedido até receber o equipamento. Qual é o prazo entre fazer o pedido e receber o equipamento e o tempo médio de instalação do equipamento?
Months from signing the agreement till fully operational system in our facility. Installation time can vary depending on the site construction. Oftentimes we've seen like just battle of the contractors, but it's anywhere between 2-3 months.
That's great. Any other questions, doubts? No? So, thank you very much,
Thank
Ms.
you.
Chiarotto. Such a nice presentation. Good to have you here. Now? Now, yes. So, Ryan from IBA.
Boa tarde. I'm here representing IBA Industrial Solutions today. And I'm going to be talking to you about primarily our phytosanitary solution, but overall our general offering of our product line. Starting with the Rototron, the most powerful electron beam generator available in the industry. But I'd like to introduce the IBA group first. And the IBA group is very capable in scientific applications for beam generation. Our primary business segment is proton therapy, where we're treating cancer patients globally as a world's market leader in that industry. We also have a radiopharma business unit that is used for cancer diagnostic applications. IBA incorporates a dosimetry business unit that is used across all of our medical applications. And the group that I represent, IBA Industrial, has over 70 Rototrons installed globally. We have three major market segments. Medical device sterilization is our largest application. We use high-energy E-beam and X-ray systems to sterilize large quantities of medical devices. We're here talking about food irradiation today. And as we've seen from other presenters earlier, that includes fruits and vegetables, as well as protein products and grains. Material processing is our third business segment, and that's the treatment of polymers to strengthen and harden them, and to be used in other industrial applications. And more in a research and development vein, we're working on environmental applications for the degradation of PFAS chemicals, wastewater treatment, and so on. The question came up earlier about the difference between E-beam and X-ray. Well, we always tell the customer when we're having conversations with them that it depends. It depends what you're trying to treat. Are you trying to treat fruit that requires only very low doses of radiation? Are you trying to treat other kinds of food products that require up to 10 gray of radiation, including protein products? Or if you're trying to treat cosmetics, medical devices, you need a much higher level of radiation applied to the product to make it sterile. And because of that difference in gradation of dose, it takes different amounts of time to treat these products. So the low density products can be treated faster. Low dose, low density is the fastest product treatment. Higher density products and low dose, such as large pallets of fruits, oranges, mangoes, papayas, etc. Those do take longer, but because they're so low dose, they're much faster than, say, a medical product. This table shows different levels of X-ray and E-beam at 60 kilowatts and gives indicative timing of how long it would take to treat a pallet of those devices. As Dr. Suresh pointed out earlier, E-beam is generally much more efficient. It's more efficient power-wise, and it's applied directly to a product. It enables very quick treatment. We can treat a box of fruit or a box of medical devices in an E-beam in merely seconds. It takes longer to treat more dense products, especially if we're dealing with them at a pallet level. For phytosanitary applications, we're generally looking more in the 175 kilowatt power range for an X-ray. It's a sufficient amount of power to provide a dose for phytosanitary applications. Where, if we're treating a mix of materials, we might want to go to a higher power level, such as 450 kilowatts of X-ray. And within those product ranges and doses, we're able to tell you exactly, prior to quoting an industrial solution for irradiation, how much product we can treat, how much of your specific product we can treat. This is an example of a phytosanitary installation. Some of our customers require cold storage, such as this. Sorry, I thought I had a pointer there. Some of our customers require cold storage, and we have cold storage indicated in the corners of this drawing. Non-cold storage is here in the red. This drawing is divided into processed product and unprocessed product. Generally, in a distribution facility or at the end of a manufacturing process, you would bring the unprocessed product into the X-ray treatment facility. In this case, as you can see, it's all pallets of material. The pallets of material are loaded onto the conveyor and brought through an area that we call a maze. Here in the after the maze is what is known as the D loop, or the treatment cell. The rototron produces the electron beam, is converted to X-ray at this point here. The X-ray treats the pellets very close together to maximize the effectiveness of the beam being created. And after a specific number of passes that are already pre-programmed into the system, because we know what the dose for the given product is, the product will automatically exit and go out to the processed side. Part of the IBA process in developing a solution for customers is that we look very carefully at the whole range of products that they plan to treat. It may be a variety of phytosanitary products, fruits, vegetables, meats, processed meats, all of those things. And we can treat them and their specific recipes in the same facility with the accurate doses and provide documented proof of full radiation treatment at the end of the process. This same facility could treat cosmetics or spices or medical devices in pallets. The reason that pallets are so effective, even though, as Dr. Suresh said, it does take longer to treat an X-ray, we need to think of the entire process of the supply chain. When these products are manufactured, they're often put on a pallet in boxes and then transported to a specific location. There's time and effort that goes into that. And breaking down those pallets and putting them through an electron beam requires labor or a significantly expensive automated process. In the case of a pallet irradiator such as this, we save all of that labor. In many cases, there's also waste, such as plastic wrap that goes around the pallets that is taken off and thrown away, and then they have to be rewrapped again. And there's waste in the transport to and from the facility. So in that way, we're helping improve the environmental impact by using pallet irradiators. So most of our customers are looking for key economic indicators or performance indicators that are important to their senior management. Whether they are contract irradiators, like some of the ones that have been presenting today, or whether they are manufacturers who want to have vertically integrated irradiation within their supply chain. They're all looking to either save money, reduce risk, cut transportation, and meet the regulatory approved processes that are required to get their product to market. Each one of our customers has a different driver. we always try to work with them to find out specifically what it is they're trying to accomplish, design a system that's going to meet their needs, then deliver that system and help them get it started operating efficiently and effectively, and then support it throughout the entire lifetime of the solution, which is typically 30 years or more. Thank you. I've managed to stretch my 5-minute presentation to almost the time that was allotted to me. And I got to my final slide. Obrigado.
Thank you, Mr. O'Brien. We still have a minute and something. Is there any question from the audience? So I'm not creative, and I have to have a isonomic treatment between the companies, so I'll ask you the same question. What's the lead time for delivering an equipment from putting the order until receiving the equipment, and the time expected to install the equipment, an IBA equipment?
Well, thank you. The lead time is approximately, thank you. The lead time from the point of order until shipment is approximately 12 to 14 months, depending on the specific product and configuration that's been ordered. We're a Belgian-based company out of the university, Catholic University at Louvain-la-Neuve, very science-based organization. Forgot to put that in my earlier presentation slide. But we ship from Belgium anywhere in the world. Typically, it takes 1 to 2 months to get all of the equipment to a site. That time period, that 14 to 16 months time period from the time of order, is concurrent with the building of the facility to house the IBA solution. So normally they align very well. The installation period is typically 6 months or more for an X-ray solution. So when I'm having conversations with new potential customers, I usually tell them it's going to take a minimum of 2 years from the time we start a conversation till we hand over the operational system. And we also have a bit of a ramp-up period because we're there with them, helping them to support the IQ, OQ, PQ process that a lot of medical device manufacturers go through. And we also help in the phytosanitary and food applications. We would help do specific dose mapping to ensure that the product is getting the required dose prior to handing the system over and giving it to them for full operational use.
Thank you very much. And applause to Mr. O'Brien.
Thank you. Please feel free to approach me or my colleagues, Aaron and Isabel, if you have any other questions during the course of the conference. And thank you again to Amazon.
Agradecemos aí aos representantes das empresas participantes.
We thank the participating companies for their contributions and presentations. We now have a session dedicated to international collaboration. And we'll have Ariadna Vargas Rivadeneira, Portfolio Manager of Ion Beam Applications, IBA, and the presentation will be now via video. And then, after the video, we'll have Aaron Taki, IBA Sales Director, will bring his considerations and will be available to answer any questions you have in relation to the video. So please, hold on a moment.
So, hello everybody. everybody. It's for me today a pleasure
É um grande
presentation with all of you. I would like to first of all apologize for not being with you in person. Unfortunately, I'm with other activities in parallel, so I'm in another country today. But on parallel, I would like to congratulate Amazon for this initiative, which I think that is crucial for Latin America in order to increase the use of food and phytosanitary radiation. So for the ones that don't know me, my name is Ariadne Vargas Rivadeneira. I'm a new applications portfolio manager at IBA Industrial. And today I'm more than happy to share with all of you this presentation. So the main goal, or my main goal today will be to answer this question on what is needed to expand the use of food and phytosanitary irradiation, topic that we addressed some months ago with some of you, but yeah, let's start to discuss about this now. So some facts, so I just wanted to summarize or to bring some bullet points to call your attention today in order to see what we can do with irradiation. So let's start from the main basis problem. So let's say 1 in 10 people fall ill from contaminated food. At the same time, we know that, for example, an estimated $5 billion are lost each year due to blocked shipments caused by pests. And at the same time, producers are asked to reduce chemicals, increase shelf life, meet export standards, etc., at the same time. So all of these are challenges that could and that can be addressed with irradiation. So irradiation is an alternative for these challenges and is here and it works. So since the 60s, we have been seeing several studies focused on the safety of food irradiation, that it can be used without compromising the sensory quality of the food. Several topics that have been addressed in the lab and also at the industrial scale. So irradiation is one tool that exists that addresses all of this. It's safe, efficient, proved, but still is underused. And I say still because in the last years, we saw that there is a tendency to increase the use of food irradiation, mainly phytosanitary irradiation, but there are still things to do in order to continue pushing this. So the challenge today, I will say, this is my personal feeling, that it's not scientific anymore. Of course, we need to be from the science going through the journey, through all of this, but it's also now strategic. We need to go to the market. We need to make relations between all the stakeholders, and it's also narrative. You will see later why. And I am including here a very nice picture of our BY solution at IBA. Why? Because in the last years, we have heard that people say, yeah, irradiation is there, but there is no technology. There are no providers designing solutions specifically focused to address food and phytosanitary irradiation. So this is an example that technology is there, and it's not only coming from IBA. There are several technology providers worldwide that could meet the expectations to process food and fresh produce for phytosanitary purposes. So what's being done today? You see this picture where I try to summarize in big bullet points the major, let's say, players in the food and phytosanitary industry. By food, I'm talking about the spices, protein, chicken feed, everything, doses that are from 3 to more kilograms up. And for phyto, we talk about doses that are 1 kilogram down for pest control. So mainly fruits and vegetables. So you see that, for example, I'm marking Mexico as one of the biggest players, that Mexico is today irradiating more than 50,000 tons per year of fruits and vegetables to send to the US. So the US is also irradiating some portions of food and phyto. I would say that it's the main importer of phytosanitary irradiated products today. Australia is also a big player with 15,000 tons per year. And China, let's say China, let's put it a mark in China, because China is the biggest irradiator of food in the world today. So they are irradiating more than 1 million tons each year, and phyto is still a pilot there. So it doesn't mean that there are not another countries irradiating food today. They are, for sure, but I just wanted to point up just the major players. If not, I will have plenty of numbers. So, and how they do that. So this is a map of the facilities today. Let's say, and it could be updated, but you can see that there are plenty of gamma facilities, and the major part of the facilities are located in Asia. So it's not a surprise that Asia and China are the biggest irradiators of food worldwide. In the meantime, US is also having some facilities, and Mexico also starting, have facilities and also in projects building new ones. So this is more or less how the map looks like. And but this is still, it's an untapped opportunity. And why I say this? Because let's think about food, the irradiated portion and the not irradiated portion. So today, we mentioned that, for example, in China, over 1.5, considering China, India, and other countries, more or less, let's focus on the spices only. Over 1.5 million tons of spices are treated globally, and less than 10% is irradiated. So this calls attention. Let's think about poultry and chicken feed, for example. China produces more than 12 million tons per year, but only a fraction receives radiation. Again, let's imagine less than 10%. So there is huge room to continue using the radiation. Let's focus on phyto. Phyto, around 1.5% of the total fruit that is imported to the US is irradiated. Those 50,000 tons, more or less, that I mentioned before. So imagine only 1.5, let's say 2% being irradiated, and what's going on with the rest? So there are other methods like methyl bromide, immersion, cold treatment, etc. But why irradiation is not increasing? So it calls attention, so we see there is plenty of room. But every time that we talk about irradiation, food irradiation, phyto, everybody says, yeah, but it's because there are plenty of barriers. Which barriers do we have? So, of course, there are barriers, but they are not permanent. Real they are, but there are barriers that could be addressed. So, for example, some standards remain fragmented. On the other side, there are some, let's say, inaccuracies on the standards coming from the outdated, or let's say from not being updated across the time. For example, the energy thresholds. I'm just bringing an example. For example, when we use X-ray in some countries, the use of 7 MeV is not allowed, and only 5 MeV. What does it mean? That we need to, let's say, punish the throughput to the half just because the regulation said, and there is no reason to say that, because it has been proved that the use of 7 MeV is safe, and Mexico, US, and several countries are accepting this. So it's just a matter of fact that the regulator didn't update the regulation. There are several inconsistencies, and there is a lot of, let's say, limited international harmonization into these protocols. When we talk about protocols, there are few bilateral or multilateral trade protocols. On the other side, negotiation protocols is really time-consuming, and even if this is allowed by the Codex or EPPC, there still face a lack of legal framework to apply it. And let's bring it back to the topic of the facilities. A lot of people say that the capital investment is perceived as being high risk or too technical. There is plenty of visibilities on who is providing the machines or the facilities, etc. So there are many unknowns. So if you see there are big barriers in this case that could be addressed, and that all are related somehow. So it's important to see that we don't need to make a revolution. We just need to have a better coordination and to create partnerships in order to support the development of food and phytoradiation. I like to call inspiration in action because we can learn from the biggest. For example, China, they have scaled from pilot to full-scale irradiation. Mexico, they apply irradiation to mangoes and other fruits. So you see that there are big players. Australia. So what they did different, or that we can learn from them and many other more, they've seen the technology, they've seen the numbers, they've seen examples, but what they do is that they work together. And one of the nice examples that I really like to call to the attention everybody is the example from Australia, where they identified all of several stakeholders and they decided to put together a group to work on it. And when I say together, together who? So I'm talking about food manufacturers, fresh producers, I'm talking about logistics, distributors, I'm talking about irradiation service providers like Benepior, Hepro, eFoods, and others that are processing tons of food today. And I'm also talking about the machine manufacturers and providers because we also need to get the information from all of these stakeholders in order to provide a true solution that could be used addressing the needs. Then the retailers, because they are an important part of the chain for being able then later to sell the products to the final consumers. And how we are going to do this? We also have the support, for example, for big organizations like global food organizations like FAO, the Codex, the IPPC, also the support of the local regulatory authorities, which I think that it's very important to work together, that you in all of your countries have the chance to share with you knowledge and to interact continuously, government, and also international associations, like for example, IAEA, the IAEA, the International Irradiation Association, and I put an example, the ESIP, the Phytosanitary Irradiation Platform. So you see that we are a big, let's say, industry, and we have several stakeholders, but some of them, they have no real knowledge about what the other does. So, and that is a big, let's say, barrier that we also need to break. And how we should do it is sharing the knowledge and experience. And I would like to share with you an experience that we had in Chengdu in June this year. So I'm talking about IFES. Some of you will remember because you were part of IFES, where we had a big group of around more than 200 people. You are not seeing the complete people in the photo, but you see that plenty of countries from different continents, we were together in one room. And what we did is that we worked together. We did a workshop in order to identify what are the main pains and how we could address it. So some of you will remember that we extracted from this workshop some collaboration ideas. So I'm putting this as an example of just only one little baby step that could be done in order to increase sharing the knowledge from all of us. And today, what we are having with the organization of Amazon is also another step, because we are having together several stakeholders sharing the knowledge and experience. And the most important is that all of you, when you go back to your country, you bring all of this and disseminate to different stakeholders also in your country. What were the main takeaways from the workshop? So, for example, we shared some sheets and they were identifying some challenges. So from these challenges, you will see that lack of knowledge, consumer acceptance is always identified as a challenge, then the lack of global harmonization or standards of protocols, some limitations facing regulatory issues. So you see that all of these are connected with what? Lack of knowledge. So what we saw, and also to be honest with you, when us as a equipment manufacturer, we want to get some ideas or some users' needs from the market, it is also for us very hard to receive an answer, for example, from fresh producers or from food providers. So when we want to go and to approximate to them, we always, several of the, let's say, the major part of times, we receive like, we don't know. And we got some collaboration ideas from this workshop. We will be working with the IAEA and with the IFES program committee in order to develop some small trainings, short videos. But you know, this is something that we might do outside. But my main message is also that you should do the same in your countries. For example, if you share knowledge with your regulator, you are not going to face a lot of issues with the regulator when you want to continuously increase the use of food and fight irradiation. The same with your customers. When you have food manufacturers that you want to bring their products to your facility, if they are aware about what you can offer them and the benefits, you won't have an issue. So knowledge is essential. Sharing knowledge is essential, and for us, we are open to collaborate with you. So, as I am getting, I already finished with my time, I would like, if you have any more questions, you have there my email. You also have my colleagues from IDA today close to you. So please feel free to raise the question, and we are happy to help you with all of these things. So thank you so much, and hopefully see you soon in person in the next one.
Excelente apresentação.
Great presentation from Dr. Ariadne. Unfortunately, she wasn't able to attend in person, but we have the honor and the pleasure to count with Mr. Aaron Starkley to be in the stage and answer your questions, the questions that you may have to our representative.
Thank you, Aaron. The stage is yours. Let's wait for questions from the audience.
Thank you. Yeah, pleasure to be here and to be among all the other collaborators and all of the other folks that are curious about the technology. Happy to answer any questions you might have.
No questions? Somebody will save me.
Hi, Aaron. So this is Patricia Wieland, Amazon. We saw from the workshop that the main cause of concern has the root on the lack of knowledge. So how do you think that we could share knowledge in a way that the producers, distributors, or interested people could absorb the information and react properly?
Well, workshops like IFAS were a fantastic start, I think, to that. So thanks for all of the collaborators that support that event and that take the time to be curious and to share and to travel from that event and share with others in the community. I think that's a good way to start that conversation. Also events like this, so folks like Amazon and EPEN and the organizations within the regions that may have the demand for these types of applications, I think would be a very good next step. I think it's also really important to continue to support the research and development organizations as well. So IBA and MEVEX and others continue to support Texas A&M University that are doing some of the research to say this is not a figment of your imagination, this is actually a real technology. And I think folks like to see the data, and the devil is in the details, they say. In this case, the angels are in the details, right? So that's where some of the discoveries can happen, and they can grow from there. So I think that's a strategy that will continue to grow over time. And it won't be long from now, we'll have the next IFAS event that will be happening somewhere near here, I believe. So we appreciate the support for that as well. So great question.
Okay, next question.
Good afternoon. My name is Yasser. I'm nuclear engineer in Amazon. So my question is about the maintenance of the equipment. We know you don't have any center here in America Latin for maintenance or for support. How it's work?
Yeah, so on a global scale, it's very important when you have this type of equipment to have the right field service technicians and the right training programs in place so that the owner's technicians, the actual operator facility, has their own technicians as well that maintain the training and maintain the competencies required and the skill sets required to keep this type of equipment operating 24/7. So the equipment providers typically provide that type of training throughout the installation process. The technicians that are going to be at the operation site, the customers, technicians in this case, will get that level of detail and training while the machine is being installed. They can actually see how things work as they go in. And then also, we do provide training centers in Europe and in the US for initial training and then continuous training as well. So that not just do we provide field service teams from our organization that come in to help troubleshoot and keep problems from reoccurring, but then we provide the training at our centers as well, so that the technicians at the operation site have the right knowledge and they can continuously make sure that those systems are always operational.
Thank you.
Yeah, thank you.
Well, since this is a question for the company, I'd like to ask Mavex if you want to say something over it. Please wait for the microphone.
So for those of you I've not had the opportunity to meet, my name's Scott Cotter. I'm Director of Sales here at Mevex. I think Aaron did an excellent job in summarizing what we provide in regards to support relating to services. A lot of it initially will take place during the installation of the equipment at the customer's facility. I know IBA has ongoing support for maintenance-related training, building those skill sets, those individuals and operators at your facilities. We do as well with the beginner, intermediate, and advanced level courses that we offer at our facility in Ottawa, our headquarters in Canada. In addition to that, I mean, we've got 24-hour service support. So if you do have an issue, whether you are operating 24 hours a day or regardless of where you are located geographically, we have service team members there to walk you through any issues that you might be dealing with at your individual facilities. In addition to that, we do 2 preventive maintenance trips annually. And then for the maintenance that may take place in between those visits, the individual staff members are trained up during the installation and then the ongoing training that's available at our facilities. Did that answer the question? Oh, thank you.
Okay. Mais perguntas? Any more questions? Yeah.
Okay, I'm Katie, and I am from Amazon. I'd like to know because in Brazil we have a hard time and difficulties about logistics. We know that. And I'd like to know if you have some success cases in other countries where you had already passed by installed devices about how they made it work, you know, to connect as we have seen on the Ariadne speakers, how we can connect the logistics and the agro business to make it work, you know. I don't know if you have some success cases to share with us.
Well, it's a great question. So I don't have any specific cases to share with you today, but I can tell you that logistics is the key for all these technologies to come together and to provide the market with the appropriate solution. Within the medical device industry, this is also a question that comes up from time to time. How are we going to plan this around our logistics? And logistics philosophies will be different from one medical device company to another. Logistics philosophies tend to be a bit more similar in the food industry because of you're moving more of commodity from place to place. But that needs to be best understood before you can decide where are you going to put this asset, where are you going to put this irradiation center. So when we work with OEMs, for example, so the producers that have enough scale, have enough demand where they can fill one of these systems on their own, they typically will be looking at putting that at the manufacturing site or at a distribution center. And from there, they can then have the product be treated and go to the market. In the food industry, it's a little bit more, actually more challenging because you have a cold chain to deal with as well. So you have to understand, it's not necessarily from company to company where the philosophies are different. Typically, it's from region to region. And the availability of the logistics and the availability of that cold chain integrity. So we do see, in Mexico, for example, it's very mature. So Mexico is shipping product from South America or Central America through irradiation sites, either south of the U.S. border or right after the U.S. border, and then throughout the market within the U.S., which of course is a very mature infrastructure. And cold chain is pretty easy to keep intact. In other regions, in China, for example, or even here in Brazil, you may have more challenges getting food from the producers to the packaging facilities, and then packaging to distribution, and then to market. So those things have to be understood. And we like to ask that question as well. What makes more sense? How's product flowing from production through to the market? And then how do we ensure that your cold chain integrity remains intact as well? So no specific examples for you, but I do know that those are a lot of questions that we like to have answers to before we get too far down the road. Yep. So to speak, down the road, so to speak.
Well, thank you very much, Aaron.
Thank you.
We don't have more time for questions right now. If anyone have any other question, please send us. We will resend to Aaron. He will be more than pleased to answer, I'm sure. And please, tell Ariadne we are thankful for her presentation, very good presentation. And just stating again, it's not an IBA presentation here. Ariadne is a well-known expert on food radiation, so and she is a speaker about international collaboration, and this is our topic. That's why she was invited, and Aaron, he kindly accepted the challenge to answer the questions for her. Thank you very much. Applause to Mr. Aaron Starkey.
Agradecemos aí a senhora.
We thank Ariadne and Aaron for the contributions that reinforce the role of the international collaboration in the radiation technology. Now we'll have a brief break for coffee. Use this break to talk to your partners, and we'll be back in 30 minutes. Thank you.
Alô? Alô? Ei, 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 ei. Ei, ei, ei. Alô, alô, alô?
Douglas. Som. Obrigada. Som. Me dá acesso ao apontador, por gentileza?
Hello?
Obrigada. Agora está gentil, né? Refrigerante e Coca Zero. Tá? Pode levar. Obrigada, viu?
Todavía no, until they come.
Som.
Tá. Acho que você apertou alguma coisinha.
Como é que volta? Colocar na apresentação. Obrigada. Me ajuda. Som. Som. Mercado Internacional de Alimentos, Workshop Amazônia. Vamos voltando. Podemos nos acomodar. Espero que tenham feito.
Let's come back. I hope you've had good conversations during the coffee break, fruitful networking.
Closido.
Vamos nos acomodando.
Let's take your seats, please.
As músicas não precisa.
So, resuming, we are going to continue with a panel called International Market for Product and Agro Products Treated with Radiation. Ingo Pogler will be the moderator, Vice President of the Brazilian Agro-Business Association, ABAG. We have the first presentation online, and the IT people are organizing to share the screen.
Senhor Gerardo, lo escuchamos acá.
Mr. Gerardo, we can hear you. Can you hear us? You can start your presentation if you want.
Me da gusto volver a continuar la plática con
Tô sem som.
So we have motivation for the whole audience. So I will complement the experience that I've presented and more details
About the questions you were asking during the other speeches. We need a well-defined background to install and operate the irradiation plants, partnering with the private sectors of all markets, users, federal and local government, and especially with investors. This will help us in an analysis of the operational costs and investments. As you see, all countries in Latin America, we are rich in raw material. The case of fruits and vegetables, we are one of the most richest countries, and we need to have the right logistic to compete and export to other countries, to have this trading relation with all countries. In the case of Mexico, we have a huge variety of fruits, and due to phytosanitary issues, we irradiate them, and all the Latin America can contribute with this type of technology, having access to markets. In the case of Mexico, it's possible that the irradiation can be increased 60-70% in the next 12 months with the opening of the new industrial plant in Aguascalientes. The important to consider for each country is that the priorities we have is to have a right certification of the technological advances and the practice we have to ensure the prosperity of every country and region and to be more competitive in global environment. In case of Mexico, we have laws that protect the consumer. Also, protocols are being created so products can be irradiated and complying with the best standards of quality and food security. In previous presentations, we considered the plant location. Where should we put it? It must be a place, a site with good access, railroads, roads, and ports, and the market open to abroad. Not only to process in the plants, but also other products like animal food, medical devices. This is the future, and it's what we see in the markets in the United States and all over the world. fruits and products being packaged, prices will be competitive, superior in quality, and the e-beam and X-ray technologies ensure the quality and safety of the products. We mentioned why technologies are important, because these technologies bring several products. We can expand the shelf life of products in other countries and continents. In the case of the mango that was mentioned, we can extend the shelf life in 4 to 6 weeks. Other fruits like papaya, strawberry, these are products that benefit from the expansion of shelf life. And with a longer shelf life, we avoid losses in transportation. So we open the possibility to maximize the prices for the producers. And another important advantage is to have access to other markets to export the products with security and quality. This is the X-ray technology, 100% green quality and safety, supported by several international agencies like FDA, FAO, and others, complying with all the requirements of these agencies. Other important resources to locate the plant is to have access to enough energy for its operation. In the case of the Aguas Calientes plant, we have this solar panel, and we are increasing the use in 50% of energy power consumption required by the plant to operate. These are modern plants, an example for Latin America. And this is a visit to Aguas Calientes to see the advance with the collaboration we have over the last 15 years. Another advance in the Aguas Calientes plant, certification of USDA office for phytosanitary treatment with X-ray. We have AFIS and ASICA, Alejandro Gonzalez, Dr. Lillian, and other collaborators. This is very important. When we saw the presentations of today, with the two technologies are necessary. Each has its specialty, specifications, and applications that are more economic than others. In the case of the e-beam, these are pet food, and these pellets are created or ionized with electrobeam. Another superior technology is the IBA solutions. This technology was proved, and one of the advances we see is that X-ray technology is superior for phytosanitary solutions. For products, and the superiority of this technology is basically the high volume logistic moves of fruits and vegetables from one country to another. So why are we talking about technology and its importance? We are talking about job creation, investments in the country and in the regions, new markets being open due to these technologies because they are innovative technologies. The complementary chains have proved economic advantage in transportation. So this type of fruits and vegetables transported and that are in supermarkets just like Walmart, they move millions of pounds of fresh fruits. The supermarkets had more than 400% in quality and in the value and freshness of fruits. And this helped also the local economy. They are stronger, and the investments made and the cost competitiveness you have when you compare to other technology. I like to show this picture in my presentations. This is the first historical picture and the first truck that transported in Mexico to the US. 2,000 days for mango phytosanitary irradiation. So the success story of these technologies covers several fruits and products, pet food, medical devices, etc. Commercial activities that we see here in these slides with investors following. They come to the plant in Mexico to see how these applications are used. This is something wonderful. The richness of exotic fruits we have with a high value in the US and other countries. These fruits should reach all corners of the world, having an extended life due to technology. We are using this principle in this type of fruit that the US is buying, and the fruit is irradiated by X-rays. So this competition is very healthy. This is the Texas A&M Center. Researches for any application we run and the future of the applications we are monitoring using this technology. This is another part of the objectives we obtain in Agua Calientes. You have the UPA people doing the tests to receive the shipment of fruits. Fruits are analyzed, accepted, and ready to the process. These are the visit of some countries, and below you see the pallets of other products that are not phytosanitary. They are cosmetics and pet products. Technology drives attention in Mexico, and other fruits like soursop, we can increase the volume capacity. The Mexican federal agencies need to continue their work to certify the producers to export their products to any other country. This type of fruit exists in other Latin America countries, but in the picture you see a pallet with fruits ready to be shipped and to be processed. And this is to show the volume that we are managing in Mexico. Tons per year until 2024, reaching 51,000 tons. We expect it to increase to 26 meaning 40% of volume increase.
Obviously, this type of discussion and capital encounter operations, many of the companies are manufacturing want to have exact figures of capacities, especially volumes that you expect to transport from different cities, also different doses to have the right volume that we are running. So there are 6 main steps for this project that may be performed in any country. All operators in Mexico are Mexicans. Studies were performed using Mexican equipment, Mexican teams. So these are working teams. We hire the best services from the best producers, designing and instruments, equipment, building companies, construction companies, and trading companies. These are operations that are important for your whole purpose. You can do it in Brazil. You have more than 10 plants. Argentina has Peru, Colombia, Ecuador. So you have the advantage, the motivation. I am not saying about future. These are real projects so that you have motivation to keep this intense work that you can perform in your countries. Here basically we see that the largest investment is for equipment. And then we have the bunker civil works, and then third place, the auxiliary equipment, electrical equipment. These are the 3 main points. And depending on the IBA equipment, solutions, map equipment, they have different prices, different powers. So we are talking about mapping better the region and what products will be sent to each region. The ideal scenario is that plants are multi-purpose plants so that they can manage different volumes, different products, so that those plants can run throughout the whole year, whether it is with fruits, vegetables, by season. And those multi-purpose plants allow us to work throughout the whole year. Well, we are basically surrounded by more than 1 billion people. So imagine the amount of customers that we can have. The amounts, the volumes. There were studies in places like Argentina, Peru, Chile, Uruguay, where we can see that the amounts are huge to transport. And with this type of technology, we are able to meet protocols from Barack Obama's bill on 2011 in order to be able to export to the United States. I believe that this workshop offers a great prestige to you all, and so that you can evaluate and assess all information that you are receiving, that you can deep dive into that information, so that you can think about the possibility of plants in Brazil and in other countries. It's also important to say that Latin America has a educational growth. a ongoing educational growth. So through seminars, workshops, held by government or private companies and the different companies in different countries. Well, those events are improving and they will keep improving and enriching the information they provide. Some years ago, I went to Africa and I saw that the African continent has a large amount of raw materials that can be exported to other countries, but due to the problems they face, logistic problems, maybe they have not been able to do so. But I want to leave here a seed of innovation that you seek in your own countries to understand how to work, settle partnerships with commercial institutions, educational institutions, the governments, because basically it's a set of partnerships to reach success, to achieve success. Setting partnerships with educational centers, investments, so that you can keep growing all around the world. Thank you very much. Mr. Gerardo, thank you for your presentation, and I kindly ask you to keep connected for the Q&A session by the end, okay? Now I invite Dr. Maria Konstanzakova, Chief of the Food Irradiation Department from Argentina, the CINIA, to perform her presentation, please.
Por acá, pero es la última.
Well, once again here, but this is the last time, okay?
Gracias. Un panorama breve haciendo.
To talk about a brief framework emphasizing to talk about Latin America regulation. They are necessary and we need to articulate it for the international market of irradiated food. Well, we have different frameworks, different situations in different countries. Some countries have regulatory frameworks that are well established. Some other countries are just in the first steps on the food regulation. And there is a growing trend for commercial adoption in many Latin American countries. But they are still limited for some products, as we could see in many presentations. Well, to perform an overview on the current situation, we could say that we have 25% of Latin American countries that has a well-developed regulation and industrial operation. 20% still do not have a legal framework and they do not irradiate commercially, and 55% has a legal framework but still they do not have commercial facilities. As for Argentina and Uruguay, the food irradiation legislation is similar. This is not by chance. Both follow the food codex and ICGFI to approve food types by similarity of food and compositions. For those for that food that will be radiated. In Argentina, it is in the Argentinian Food Code since 1988. In 1970, this plant was opened. In 1988, the legislation was approved for food irradiation, but only for 8 specific products. What did make any sense? Garlic, potato, onions, spices, some other dehydrated elements, mushrooms, and some fruits like strawberry, asparagus, and one or another thing. But this has changed in 2017, and there it was approved the type approval method. Uruguay was the same thing, by type approved since 2008. So the classes, the types or classes I've mentioned are these ones. Article 174 was updated in 2017, and these 8 classes, food classes, were added, introduced. So for each of them, we have different irradiation goals. Some classes have different possible applications with different goals, like insect devastation, microorganisms control, and phytosanitary control. So let's imagine 1988 on the National Atomic Energy Convention. We've been promoting and updating the legislation. In 2015 and 17, we celebrated with champagne. We celebrated that change and thought, oh, it's going to be amazing. It will be great improvement for us. Well, it was approved fresh produce, meat, frozen products, fish, and phytosanitary. So okay, now it's going, but no, it got stuck. And I tell you why. This is what happens. Although it's approved by law, the Argentinian code, there is another body called SENASA, the National Service for Sanitation, Food Sanitation. That it's quite the agency that is the owner of the phytosanitary part of the legislation. So they are in charge of meat, fish, and others for commercialization, internal commercialization, and also for exportation. And each Argentinian distribution place, we have inspectors. So the treatment needs to be part of SENASA regulation, both for phytosanitary treatment, but also for animal food or food-based, animal-based food. So by 2023, it was incorporated by SENASA regulation, these phytosanitary measurements. So they adopt the Rule 28 that approves. So what has happened? So we do not have large plants able to process huge amounts of food for phytosanitary, and still we need to train the inspectors, because the auditors, because they are not used to that. We do not seek to kill the insect, but rather to sterilize it. So we've collaborating with SENASA to provide training, education, and the SENASA team attends the workshops that we promote, among other moments. So as for meat, fish, poultry. Senasa still didn't add the treatment for those products. What I mean, it is in the law, but not in practice. It is not at Senasa, so it cannot be implemented. There is great interest from the industry to do so. Some years ago, when the food code was updated, there was an interest on concrete investment to handle those types of meat. But as we didn't have the legal framework, complete legal framework, the idea was discharged, dismissed.
As I said, in Uruguay, the classes are very similar. But class 5, that includes all types of meat in Uruguay, is only poultry meat, as far as I know. And then we have other regulations in Latin America. In Bolivia, they are working to consolidate this regulation. In Chile, the sanitary regulation includes ionization since 1996. In Colombia, there is a partial regulation. In Costa Rica, it's regulated since 94. And Mexico, we have just seen. We don't need to talk about Mexico. It operates under international standards with commercial plants and well accepted to export to the U.S. Paraguay, regulated since 1999. In Peru, active techniques. In Dominican Republic, there is no. And Venezuela since 2008. And let's talk about Brazil. So, round of applause. How can you transform this in very simply? Because it's approved to everything necessary. You have the approval, the minimum dose absorbed to reach the objective, and the maximum dose does not alter the product. Okay. So what else do we need? So congratulations, Brazil. Then you tell me the secret, how we can convince the public agencies about it. And what happens with the labeling of irradiated food? The legislation says that it is necessary to have a label using this international symbol. And everyone needs to include this: food treated with ionizing energy. On the other hand, as a food technologist, I don't see labels for food treated with pasteurization. Well, and this happens with Mercosur. We have a similar regulation, but they are not unified. Not only for radiation, we have several other fields of food industry where we find discrepancies. Every country does its way. In Argentina, they approved the regulation of healthy food with critical nutrients, excess of sodium. Well, this is a different subject, but anyway, we have problems in the commercialization within the countries of Mercosur and Latin America. So the application of these stamps, so to say, is not uniform. But we are talking about irradiated food. It's necessary to harmonize the doses, as we saw in the case of Argentina. Limit doses were established. The countries, they do not approve by category. On the other hand, we mention legislation now, it will be necessary that all countries to behave likewise. So, what are the barriers and challenges? Lack of regional harmonization. We have gaps, legal gaps, and differences in the regulatory framework in the countries, a lack of articulation among governmental agencies. We need to update the standards following international references. We need to have this technical capacity and surveillance. We mentioned that the SENASA inspectors in Argentina, they need training. They need inspection system, and Latin America really advance in terms of technical and regulation. Most of the countries have a regulatory framework, but it's necessary to harmonize the infrastructure. We know that radiation is a fantastic tool, safe, efficient, clean, that strengthen the food security. But it's moment to go from regulation to commercial implementation. In some cases, implementation, and some others to increase the scale. And it also requires strategic policies by the country to foster the technology and to have a total focus. So a well-defined regulatory framework with a total coordination among official agencies, infrastructure, new plans according to every purpose, and communication to consumers, and obviously financing. Well, that's it. Thank you. Now I invite Mr. Ivo Ploger, Vice President of the Brazilian Association of Agribusiness, to moderate this debate. Welcome.
Boa tarde.
Good afternoon. Since we are in Latin America, I will speak in Portuguese. So I apologize to Mr. Gerardo for my Spanish, and also Constanza. I will speak very slow Spanish so we can have a better understanding. I'd like to start greeting Gerardo and Constanza for their presentations, a very didactic and clear presentation that really motivate us. The first part, it was very interesting, Gerard. Since you were a businessman, how you can employ and invest in different stages of evolution, aiming at the North American market. That is one of the most competitive markets in the world, where not only the quality, but also the logistic functionality and entry of novelties in product. And it was interesting to see the branding issue in a much more phytosanitary issue than radiation. This really drew my attention. And you, Constanza, you showed how is Latin America, and it's interesting that one part is well advanced, like Mexico, more or less advanced, like Uruguay and Argentina, advanced in some regulatory issues, like Brazil, but we don't have nothing in production. This is what we have in Latin America. And being here, well, ABAC is the Brazilian Association of Agribusiness, integrating from the production, logistic, transformation, up to the consumer part. We strongly support legislation and this technology because it shows to be technology of advance that provides several possibilities, not only a better access, but to improve the costs, storage, and also not losing quality. But the 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 possibility of having the product on the shelf. Well, we have a very interesting audience here. Gerardo, if you were in Brazil and if you were Brazilian with lots of money, where should you start your investments? Well, this is a very intelligent, smart question. I think I have the answer. Where should I start? How many plants you are going to install in Brazil? This would be my first answer. Why? We studied Brazil and also Latin America, and I can tell you that you have one of the best countries in the world with logistics, necessary volume to export from Brazil anywhere in the world that we really appreciate the value of the commodities. Much of the logistic in the south or north, depending where is the location, it's a commercial area, agriculture, but we can put together other centers, spices, pet food. So I will give you an idea in this sense that most of the plants we build start to run within 2 or 3 years, and now we are duplicating a new plant. And at that region was really difficult first to break the monopoly of other technologies, to break the monopoly of the competition. But the satisfaction you have is that you can tell to FDA and other international agencies, you can say the benefits of the technology, E-beam and X-ray, are much superior than other technologies. It's not me who is telling this. The inspectors that come to audit us, those who inspect the trucks, they also say this. I think you have a very good proportion because Brazil has important ports, and one of the conditions you can help us is to increase up to 10,000 indirect jobs when you install a plant like this. Thank you, Geraldo. But you didn't make me easy because you didn't say that you were coming tomorrow to Brazil to make an investment. But on the other hand, I'd like to ask you, do you know Brazil? You do know Brazil and you do know the productive capacity. And you mentioned logistic, location, energy, and several other subjects. We saw in your presentation and in the others that we have some locations where we have concentration of fruits that we can export by plane or using containers. The other are animal protein. And here we have big players who could do this direct in their production line. And third, we have multifunctional going through cooperatives that we could do it. So my question is, what would you start with? Fruits, protein with large production, or multifunctional? What is better for you?
Well, my answer would be based on the experience that we've developed. The success would be to have a multi-purpose plant. Spices, proteins, and fruits. There are many locations we could use. There are very positive alternatives. That's why I usually say, how many plants can we install? Because your exporting capacity is unique in Latin America. You have an amazing capacity on volume. The only thing that you need is to be sure and say, okay, today I will start the first plant, and then I will tell you. If you put together three areas, protein is the number one, and basically you have a huge amounts. Because when we started at Aguas Calientes, we had 17 product types. Today we have more than 200 different companies. Thank you. And extra curiosity. What do you think about the future? Do you think we will have this type of investment allied to the producers, so fruit producers, that will have a season, or would we have a service that will be provided to others? How do you see as the most probable way to the future? This is a smart question, a good question, and I will answer it with great confidence. In order to have a balance in the plant, you need to start inviting users to be investors on vegetables, whether they are pet products, frozen products, spices, or cosmetics. These are the first potential investors that you should invite. And then you go to other investments, banks, investment funds, and then you will diversify, and you have a defined authority on the type of products you're going to work with, so that you have a volume that you are able to manage. I can tell you that what we sell in this type of service, well, we sell our machine services. So a multi-purpose plant is exactly that. You rent the machine to produce. So you have cookies, and you want those cookies to have a shelf life of 200 days, for example. So you can be on different countries like Uruguay, like their cookies, their biscuits. But the lack of shelf life prevents you to go to other markets. So with that, you can increase your installed capacity. You have grains in Brazil, and this type of company would help to have a larger use margin because you can store grains for many years and you can manage price, seasons, dry seasons. So that type of situation helps you to manage the plant. So my answer is definitely you need to start with users that will help you to penetrate the volume of the plant, and then you have some margin for new clients, new customers. Thank you, Gerardo. This last part is quite stimulating. You know, in our tropical agriculture, we work with 3 harvests per year, and the pressure on logistics, on storage mainly, is different from the North Hemisphere, where they have only one harvest, and then they may keep the products for more time, for a longer time. This is a different logic, but what you say exactly is that you bring in extra life. So you could work with different logistic and storage strategies in a different flow. And this is an amazing topic, but it will always be impacted by the CAPEX and the OPEX. And my last question in this round for you would be with what return over investment you expect for a project like this one? 40% after taxes. Okay, thank you. Now, Constanza, I would like to ask the same questions to you. Well, you come to Brazil full of money. Well, we need to harmonize Mercosur. I understand that Argentina is ahead in many points as for harmonization, norms. I understand, on the other hand, that Brazil, as you said, has a very open legislation. Easy, maybe. I don't know if you are so sincere because you are in Brazil or because it really is. Because usually our standards are not on the top but rather in the bottom. So if it was like you say, it would be very interesting. So my question is this a determining issue for the lack of investment in our area, or we are not brave enough to have it more coordinated? I believe that complete legal framework is important. At least from what I know in Argentina, where we had investments. So knowing our times and all the bureaucratic issues, investors, who will invest in something until we have the legislation, regulation? So we have other times, other needs, other investments. The legal framework is very important, a complete, adequate legal framework. It's not the only thing. Brazil, for example, you have all the conditions, but commercial irradiation it still has a long path ahead. So, what comes first, the egg or the chicken? I don't know where to start from. I think it needs to be everything at the same time. That's why I talk about the strategic perspective for each country. We need to see the advantages of that technology in order to open new markets. You know, so many examples. We've talked about phytosanitary, but for example, in Argentina, we have the exportation of fish or fishery products. So these are different products, perishable products. So if it's not frozen, it will not last long enough. So we've worked with the Mar del Plata University at Calamares about the calamares. So they tolerate for refrigeration, and it can reach 1 month as for squids when we irradiate and froze. The price and the quality is not the same thing. That was frozen. So for each product, we can see examples where you could potentialize markets for each different product. So I don't have an answer for that actually. Well, we need to put Chile in the table because Chile is a great producer and exporter of fishery products. Almost everything transported by plane, so they are very competitive. If we brought them to the debate, it would be quite interesting. The second point is that, as you said in your presentation about the branding, our countries had during the last years many experiences related to sensitive subjects. So I could notice that. For example, Gerardo said, we are doing this due to phytosanitary issues. We are not doing brand washing. This is very important, relevant for to avoid loss. So I'd like to know the Argentinian and Uruguayan experience on that sense. Is there any resistance from people or not? Well, as I said, when the food code was updated, it was disclosed. It was on newspapers, TV shows, TV news. They were saying no, they want to poison us, and this is still there. But how can we blame consumers for being afraid if even our regulating bodies resist to approve some elements? So it's a type of food conservation. It's the most studied food conservation method in the history. It is approved by the WHO, many food controlling entities. So what more they need? How consumers will complain well, they do not trust it. If they mistrust it, is that because the agencies are not helping in that sense? For example, the United States with that irradiated meat situation. Well, with that logo that is there not only due to a legal requirement, it means that it is good. Your kids are protected against diseases. So I think that would be a path. Thank you, Constance. Gerardo, I have a question about the American market. Y- You did a great work in the United States. Between Brazil and the United States, right now, there is a different environment. I would say that they are, engaging, they are dating. Now, Lula likes Trump, Trump likes Lula. We don't know the end of this love story. So, I would ask you, how do you see the Middle East market? Middle East has a great need for food, for fruits. A older conservation idea that for sure countries like the United Emirates, they need that. So how do you see this situation? It is quite important. This is diamond that we need to trim intensely in order to penetrate that market. A market that has first added value, so there is a great margin on their products, and they are also seeking food safety. If you have products to sell to them, they will buy whatever you want to sell, because this is a market that demands food. They need to have food security. So if you have this purpose of opening to this market, congratulations, because it will be very important for the Brazilian economy. Constanza, let's imagine that by a magic trick we settle an agreement between Mercosur and the European Union as a Christmas gift. Would be this a good news for products, or would be rather a dilemma? Wow, hard question. And I'm this crossroad situation. How would I say that? It depends on the product. But I would say that one of the reasons or fears in Argentina for irradiating meat, for example, our main market to be the European Union. So we have this dilemma. In my opinion, this is a misinterpretation. But okay, this is what happens today. We have a constant conversation to change this way of thinking. We have the same perception, I think. I believe that European Union has even more severe restrictions than the United States and China. So my question was exactly that. Do you think that this could be a challenge on exporting to the European Union? Or it would be a new subject that you can bring to agenda so that we can have a more rational discussion? Based on your experience with the European Union, what do you think? Do you think it's going to be hard, impossible? I have no experience like that. But when I'm talking with other agencies like Senasa, those concerns come to the table. So we need to think about European Union. There are many business people from the meat industry that have created slaughterhouse consortiums, going to Senasa and pressuring for this approval. But although, even with a concrete interest from the industry, those regulatory subjects are quite hard. We are thinking about China. And it would be great. So, well, we cannot limit ourselves to think that European Union or trading with the European Union would define the thresholds for other opportunities that are very important as well.
Thank you. Is there any problem with the WLO? Adriana will help us in these issues, not only for Brazil, but for Latin America. You don't have allies here, okay? Gerardo, I'd like to thank you very much, as well as Constanza, and say that money is not the problem, but the date to come investment, because there is a line for investments. Amazon is already including this as an opportunity. So please establish a date to come to Brazil. We'll be very pleased to receive you and to listen to your considerations. Thank you, Constanza, to be here with us and for opening your heart for things we should do. And for the Brazilians, I will speak in Portuguese. Thank you for your words. And thank you for your invitation. And we go to Brazil to live for the first plan. Oh, extraordinary. Thank you. You see how things are easy now, Gerardo? And come to Argentina as well, please. Since we have lots of collaboration and everything you did, opening a plant in Argentina, and I'm here at your disposal. You have the intellectual capital, very important, great capacity of having not only one but several irradiation plants. And what you can tell the investors is that this opening would be excellent to break the monopoly of technologies that are already becoming obsolete. And this would be very important to the country, especially in the economic sovereignty and producers who want to export to other countries. Thank you. So thank you. Tomorrow we have more. And what we see, and this is great, we are wasting time. The opportunities we saw in Mexico and Argentina ahead with many things together with Uruguay. And since we have business capacity and financial capacity now, we need to make it work. So this is a huge opportunity, and we should address this issue in a different way. Who knows? Thank you. Thanks, Amazul, for this opportunity, and have a nice day. I give the floor back to the moderation. Amazul, thanks. This is smart moderation and the clear way the debaters address this subject. We are ready to close. Please show the slide so we can continue here with our closing. The discussions of today showed how much the integration among science industry can ensure the safe use of food irradiation. We close this first day of the Latin America workshop with results far beyond the situation. We also thank your presence, and we will meet again at 9 a.m. to continue our agenda. Thank you.